to have that's a pretty early time to have to put an end to daily activities. More than this though, we hope access to energy would allow the people of Cabway the freedom to put the energy to use wherever they think is most suited. You can go to the next slide, please, Aishin. Now I hear you say, they do have power at school. True, they run on diesel, but diesel generators are complex and come with a host of problems, including difficulty to fix and maintain, difficulty in acquiring and paying for fuel, and of course, the environmental impact of burning fossil fuels. So a renewable energy source will be what we're looking for. Solar panels and wind turbines are what everyone jumps to. We looked into both. Not only did we find them expensive, but given their complexity, we found that they simply weren't worth the trouble. How about a slightly more exotic form of renewable energy, like hydro or biofuel? Well, the country already has a lot of hydro, but there's no easy implementation in Cabway. And after doing some research, biofuel is only really feasible on a pretty large scale. So what are we to do? We need a sustainable energy source that's cheap, easy to maintain, and can be integrated into the community. Our solution is the packaged wind belt. We would source the most difficult parts to obtain here in Ireland, package them for less than €10, ship them to the school where it would become a class project to build and learn about the mechanics demonstrated by the wind belt, while also being a clean source of renewable energy for the school. I'll now hand you over to Aishin, who will get a bit more into the specifics of the wind belt.
So the components of the wind belt are relatively simple. The frame will be built on site by the children using local materials, whereas the rest of the parts will arrive to the school assembled. The membrane will be made from a lightweight, low stiffness material that can be pulled taut, so cassette tapes or mylar would work here. It also contains neodymium magnets, so these and the components for the stators and rectifier will have to be provided in the kit. In total, we expect each kit to cost just above €7. A simple overview of this design is that wind flows through the frame, causing the belt to resonate. This movement is then turned into electrical energy. The wind belt works by using electromagnetic induction. The membrane holds neodymium magnets, which interact with the stators on the frame. So when the membrane flaps, the local magnetic environment changes. This change relative to the stators creates an induced electromagnetic current through Faraday's law. This is a concept that the children could learn about as they're helping to set up the wind belt. Of course, the magnets will be moving both to and from the stators, so we need a full wave rectifier to take all of that energy out of the wind belt. This allows us to capture twice as much energy as if we used a simple diode. Although it is turbulent, the wind will cause the belt to vibrate near a specific frequency. The belt will have its own preferred frequency too, at which the amplitude of vibrations will be largest. We can change this natural frequency of the belt by adjusting the tension. When the belt's natural frequency is the same as the frequency produced by the wind, resonance occurs. This will then greatly improve the efficiency of the belt. Maximum amplitude means maximum movement of the magnets relative to the stators, which means maximum energy output for us. Normal wind speeds in Cabway are between 10 and 15 kilometers per hour in the dry season. While the wind belt is efficient up to 38 kilometers per hour, higher winds may only occur in the wet season when the wind belt might need to be taken down for safety. Unfortunately, because the wind belt uses turbulence to generate movement in the belt, there are no formulas that can tell us exactly how much power could be generated. Experimentally, however, the efficiency has been shown to be between 0.21 and 0.53. This allows us an output of between 10 and 100 milliwatts for even a small wind belt. Our hope is that we can get enough supplies to the school to build some 1 meter wind belts connected together in a panel. We hope that this would allow power output to be in the watts. So I'll pass you over to Kate now, who'll talk about the implementation.
So our aim is that the school children will not only be provided with a sustainable energy source, but also the opportunity to learn about harnessing this energy themselves through the assembly of these wind belts. This process will allow children to develop scientific and resource management skills. They will learn about Faraday's law and the basics of electromagnetism while building these wind belts. We have created a comprehensive instructions that the teachers in the school can use as a guide when teaching the children about how the wind belt works, ensuring that the children can fully understand renewable energy in a real life setting. The instructions can be seen on the slide. They will also be part of taking the wind belt down when necessary, for example, during the wet season. Just the next slide there, Oisín, when you're ready. Along with recycled materials such as wood, old plastic, or scrap metal, that can be easily obtained in the community, they will also be given parts that will be difficult to find in their locality, as Oisín mentioned earlier. Wind energy is entirely renewable. The only environmental impact in the wind belt is the embodied carbon in the materials used to build it. Hopefully, this can be offset by the use of recycled materials, as there is a very low net carbon footprint. The wind belt is designed to complement other power sources which are unsustainable. This wind belt encourages sustainable practices within the community. What is perhaps more important than the electrical energy that these wind belts will generate is the potential energy. The children in the school have great potential to create positive change in their locality, and we believe that the real value in the wind belt is in its ability to power this new generation of innovators. We believe by integrating this into the community, not only will they gain a renewable source of energy, but we hope that it will propagate innovation within the school and community. Thank you so much for listening.
Brilliant, thanks very much, guys. And you came in under the 10 minutes there as well, so well done on timing. Great stuff. Also, apologies, guys, I realized I had forgotten to press record earlier in the meeting, so apologies if you heard that little announcement there in the middle of the presentation. Anyway, thanks so much, guys. I will pass over now to our judges. So we'll just give 5 minutes for that, and just arrange so if people want to, whoever wants to maybe jump in first.
Hi, guys.
Oh, yeah.
Well done, great project. I was very interested in the oscillation being converted into energy. Just two small questions, right? One, you were saying the maximum, the belt will cut out at 38 kilometers per hour when it reaches its max wind speed. Is there a mechanism there that stops the belt? Are the people to be aware of this? And if so, how is the wind speed measured?
Yeah, so I don't think a mechanism is really needed. When I say the maximum is 38 kilometers per hour, I just mean in terms of efficiency, you know. Yes. So you can get a lot more power output at high wind speeds, but past 38, it kind of maxes out.
Very good.
In terms of when it would need to be taken down, would just be kind of situational. You know, if there was stormy weather, maybe in the wet season, then you know it might be best to take it down. So I'm not sure if the wind speed itself would really need to be measured.
Right, very good. And then the question of converting to DC, what mechanism do you see being used for that?
We'll be using a full wave rectifier. So I have the circuit diagram there if you want to see it again too. Or...
Good, very good. Excellent project. Thanks very much.
Thanks.
Great, thanks, Owen. Anyone else from the judges want to?
Yeah, do you mind if I just have one? I thought this is really, really interesting, especially, I mean, you could see it being feasible, hopefully, but I wondered about, you know, training the teacher. Obviously, like a teacher needs to have tried this out themselves before they're going to attempt to do it with a class. Have you thought about that maybe there could be a Zoom call with the teacher or teachers who are going to then demonstrate this for the class?
I think we would be happy to do Zoom calls if they were needed or if you were able to. But I guess the thing about it is that it's more assembling it as opposed to building it. So when we give them the parts that they need, it shouldn't be too complicated for them to put together. And I think definitely over a Zoom call, we'd be able to explain any queries or, you know, kind of just make it nice and simple for them, because the actual assembly of it isn't too complicated once they have the parts.
Okay, actually, yeah, I suppose a science teacher or whatever would have no issues with it. All right, thanks.
Yeah, probably, yeah.
Thank you.
Great stuff, thanks, Anne. Yeah, Pradita, go ahead there.
Yeah, so like I wanted to ask about the adaptability. Like I think my internet broke a little bit over there, but when you said you know we could take it out during the wet season, is there any particular reason for doing that? Like you know, just to know more about the adaptability of the this system.
Yeah, the only reason for that really would be if it's not completely stable. I mean, we are providing all the parts except for the frame. So the frame could be built from wood or scrap metal or anything they find locally. So I guess it would be up to them to decide how sturdy that is and how long they can be kept out for during the year.
Okay.
That answers your question. Thanks.
Yeah, that does. Thank you so much. And my another question is like, so when you mentioned about it would cost around €7, that would be the materials that's you know that you guys have worked on, right? And have you considered it you know in the like how much it would cost you know in the local market there, like while we need to maintain if we need to maintain the you know the system and stuff like that. Do you more in that?
The €7 actually includes spares for the parts that are most likely to break, like the mylar. I think so. Like we have plans to make a meter long wind belt, but I think there can be like 2 or 3 meters just in the package that we give, and then I'm pretty sure an extra magnet is also factored into the cost there. So like the difficult to obtain parts are all within the package for the price.
Yeah, we also looked into the price of shipping. I think, Oisín, do you have that on hand? But also, yeah, it's a good point to work with the sort of local community, see how many parts we could get. But obviously, it's hard enough to find that out from home.
Okay, great. Just maybe one more minute there, Aravinda.
Yeah, I had one more question. Yes, of course. Thanks, Emma.
Yes.
So my question is, how many of these would be required to replace the diesel gen they have?
So I believe what we were hoping was that it would supplement the diesel generator, because for as cost efficient the wind belts are, I don't think they could fully replace the diesel generator without a lot of them. I don't think we have done calculations to figure out how much it would take, but it would require quite a few, I think.
Okay. Another question I had was related to that would be, let's say if you had one of these, what would that be useful for? Would it charge a mobile phone? Would it run a light bulb? Just one kit, what would it do?
We were hoping that it could charge like a phone, external phone battery. So then it could be used to charge a phone or a light bulb if you had an adapter that could plug a lamp into a phone charger or phone battery, I suppose.
All right. Okay. Thank you.
I think as well, just to add to what Oisín said, a big part of this project, we kind of came to realize as we went along and we were doing it, was we really want to spark an interest in the students. So, even though this idea might be able to replace a diesel generator, that they might be able to get interested in this area and be able to create other ideas themselves to create energy, because they know their resources better than we ever will, because we haven't been over there. So I think that was something as well that we realized that we'd really love if we were able to spark an interest in the school children.
It's a very interesting educational tool, definitely. But my question was actually the same as Pradita's, that if you're shipping things out there and even there are spare parts, what happens when there are no more spare parts? It would be important to be able to source that locally, or even manufacture it completely locally, without having to worry about trying to ship more parts in a year's time or whatever. But it's very, very interesting educational tool, definitely, for the school.
I think as well on that, probably more than we weren't able to find out fully, but I'd say within some sort of local region like that's closer than Ireland, they would be able to source certain parts. You know, and it's just a case of us not being able to find out that that is possible. So I think we would hope that we'd be able to keep it closer to home for them as well.
And like some of the parts can have like surprising replacements. I think Oisin mentioned it, or maybe Kate, like the mylar membrane can actually be replaced with like from oh god, the word
Cassette tapes.
Like a cassette tape, is it?
Yeah.
Yeah. Or you know, the stator, the main component of a stator would be the copper wire, or so that wouldn't be too difficult to come by. Yeah.
Okay, great, thank you. Thanks very much, guys. So we'll move on there now to our second project. So we're moving now to our first student from Waterford IT, Alan Fitzgerald, with his project Phases. So Phases involves a series of buildings that will be spread out over 3 individual stages for the development of Chilea Village School. And these clusters aim to reduce the vastness of the overall site in order to create more enclosed and protected teaching spaces, both inside and out. So Alan, I'll pass over to you there now.
Okay, thank you. Okay, is that visible? Yeah.
Yeah, all good, Alan. Yeah.
Okay. Okay, everybody. So my name is Alan Fitzgerald, and I'm part of WIT's architecture degree. And once again, the name of my project is Phases Chilea Village School. So from my site analysis, what stood out to me most was the vastness of the overall site. And then secondly, the 2 distinct site zones, which I've labeled as Site 1A and Site 1B, which are separated by 2 traffic routes. Now, from these observations, the main aims of my scheme are to reduce the openness of the overall site through the construction of clusters, which create more enclosed and protected spaces, to respect the existing buildings and to work them into the overall design approach, to create flexible teaching spaces both inside and out, to use sustainable materials, on-site construction practices and local craftsmen and women, and finally to connect both of these 2 site zones through the implementation of 3 individual phases, which will also create a framework for future master planning. So if I just go up to my concept models and sketches, you'll see that I'm using a trellis structure which connects the existing buildings to any new construction. So essentially the trellis will link old with new, but it'll also provide shaded circulation and social spaces as well. And then I'm just going to bring you down and walk you through my plans. So we'll start with phase 1. Phase 1 corresponds with the already existing school building on the site. And then it offers a kitchen, 2 additional classrooms, a library, an exterior teaching zone, a science lab, and then staff accommodation, which can be adapted into administration purposes as the development continues into phase 3. Adjacent to the phase 1 cluster will be the toilet block, which offers 10 cubicles. Now phase 2 then will offer another 2 classrooms. We'll also offer an additional outdoor teaching zone, a large and open insaka, which is a community space. Adjacent to that will be a vegetable garden. And the vegetable garden, the large insaka, and then the additional water pump in the central courtyard, it won't only be used by the school, it'll also be used by the wider community as a social space. Moving then to phase 3. Again, phase 3 works with the existing building, which will be adapted into living quarters and will be joined by an additional dormitory and toilet block. And this will offer living facilities for staff, but also vulnerable children. So children who not only need a place for education and to be fed, but also who need a place to live as well. So orphaned children. And then everyone, just to recap, with the site plan, I have phase 1 here, which works with the existing school building. Phase 2, which looks out onto the football and recreational field. and then finally phase 3 in site 1B. So now I have a concept sketch of phase 3, as well as 2 elevations of phase 1 and 2. And these elevations highlight the trellis structure, which works between the existing and the new buildings, and also the exterior teaching zone. And then I have a model photo here, which shows you how that trellis structure creates shaded circulation, meeting and socializing spaces. I'm going to move down then to my sections. So section B highlights the interior of one of the classrooms, but it also highlights interior wooden panels. And these panels can be folded back and used to open into other classrooms, but also out onto exterior areas. And this just creates a flexibility in the teaching spaces, but it also aids in efficient and increased ventilation as well. Now in section A, these panels are highlighted, but the exterior teaching space is also highlighted there in the background. And then the model photos to the right-hand side here just bring these elements to life. Now everybody, section B also highlights the toilet block over here to the left-hand side. So it's common practice in Zambia to build latrines on the periphery of a site, and then to move them or rebuild them once the pit is full. And this just means that, well, it can be a waste of resources, but it also means that it creates spaces for sometimes antisocial behavior, and also in the worst cases, areas for sexual assault. And during my research, I found out that one of the main reasons for female students in particular dropping out of education early is due to these unsatisfactory and dark toilet facilities, which they can find very intimidating. So I've addressed this by creating a toilet block which has a large enough pit so that waste can disintegrate naturally over time. If there is an overflow, if there's an unlikely case of an overflow, rear access can allow waste to be removed manually. And this just means that the toilet block can be used indefinitely in its current position, which is a much safer and much more central location as well. Now the roof is raised and it's also pitched, and this allows for rainwater harvesting, but it also allows for natural ventilation as well. And this removes odors and germs, and also creates a light-filled space. Now, a bamboo ceiling will be used above each cubicle. So this again will allow for light penetration, but also privacy. Now, if bamboo cannot be used for whatever reason, alternative materials include banana fiber, as well as kitinyes. And kitinyes are woven wreath mats, which are made by local craftspeople. So the final page of my presentation will deal with the structure and the technicalities of the project. And I'm going to start with the roof structure using photos of my structural model. So the roof structure consists of inverted monopitch timber roof trusses, and they're spaced at 2.5 meters apart. Purlins are placed between these at 1.5 meters apart. And then a layer of tied bamboo will be placed on this structure. This will aid in soundproofing, particularly as I am using a corrugated steel roof. A layer of foil then will be used for heat reflection. And then battens and counter battens will be used to support the corrugated steel roof. So the walls will rest on a rubble foundation. The floors are of rammed earth and 6% cement. And then the walls themselves are made from compressed stabilized earth bricks. Now these are 40% cheaper than clay bricks. They're biodegradable, pest and fire resistant, and also they can be made on site by local craftspeople. And because they do not use an oven, which requires firewood to fuel the oven. They also aid in the reduction of deforestation, which is a major problem in Zambia. I'm just showing you my overall structural model here. You'll see that between the trusses, there are vertical lattices, and behind that would be a fly screen. And this just aids in further ventilation and creates a cool internal classroom environment. Now, one of the most important parts of the project is the ability to take advantage of the expansive roof spans for rainwater harvesting during Zambia's wet season. And I did a calculation for phase 1's roof, which is 700 meter squared roof span. And then taking the average minimum rainfall during Zambia's wet season, I came up with a capacity of collecting 661.5 cubic meters of rainwater, which can be stored and then used for daily use for the children and staff. And this just reduces the overuse of the water pumps and the Earth's natural water reserves. And then finally, everybody, I just want to end my presentation with a concept image of an exterior teaching space, because this is what the project really comes down to. An effective, comfortable teaching space. You can see it looks back into the interior classroom, out onto the Nsaka, and then out onto the courtyard beyond. Thank you.
Brilliant. Thanks very much, Alan. Well done. So over to our judges there now, whoever wants to jump in first with questions. Maybe Anne, I see you there if you have any you'd like to share.
Okay, don't put me on the spot or
anything.
anything.
If not, sorry. or Pradita, whoever.
Yeah, no, sorry, I'm joking. Alan, that was great. I just think you've thought of so many things. I love the compound idea and the fact that you consider that for security as well, which would be important, and that you could put gates up, and that was all really good. The toilet blocks all was very important. Yeah, I was involved in a thing in Ghana one time, and I remember helping build a toilet block on a volunteering project. So I'm well aware of that. Now, you didn't really have time to go into it much, but I like the idea as well that you are considering solar panels, and it's not something that you could put into these 3 phases perhaps, but what do you think the possibility in the long term is that those roofs could host solar panels?
Yeah, they could definitely hold solar panels. Now, I didn't look into kind of pricing or just how many might be needed and how much that would cost. But I can't see any problem with those roofs holding solar panels.
Okay, so maybe for a further stage and a further phase that could be considered.
Absolutely, yeah, the next stage, and I put that in my write-up. Yeah, that'd be something I'd like to look into further.
Brilliant. Thanks very much, Alan.
Thank you.
Thanks, Anne. Pradita, I see there's on screen if you want to jump in.
Well, not a question though. I just wanted to say it was a really nice presentation. I really loved the concept, and well, yeah, I was about to ask about the, I mean, not ask, but comment on the security, but as Anne has already, said, so yeah, I'm quite impressed with that. So just one thing, like you did mention about the orphan, the students who could live there. So would there be, just connecting those two, like the children would be there living, and about the security issues, so just to, be more, how do I say this, like basically making it much more secure would be really nice. Yeah, so yeah, I really love the concept. Thank you.
Thank you, Pradita.
Great, thanks, Pradita. Owen there, do you want to jump in?
Yeah. Alan, thanks. Great presentation, and definitely an awful lot of work put into it. I can see the thought process there and the things you consider there in terms of security, the design itself, the capturing of rainwater, and then the use of local materials as well, if possible. Will the building be completely composed of materials that can be sourced locally? And then if so, I suppose using those materials and the cost, I know that you have it done on a phase basis there. Did you do an estimate of the cost of each section, or was that within your brief?
I didn't do an estimate of the entire project. I did. I spoke with an architect who has worked in Zambia on projects, and she was able to give me an estimate cost for phase 2, which would be about 100,000.
Well, the idea of then utilizing the rainwater from the roofs and collecting that rainwater, would that be for potable use, for irrigation and for toilets, or is it for drinking water? Would that be drinking water?
I'd have to recheck that again. I'm sure if it was treated, it could be, but it'd be for irrigation. It'd be for the kitchen in particular, for cooking. Irrigation for the vegetable garden, and then for the toilets and hand washing facilities as well.
Yeah, excellent. And then one last question. In relation to the use of the large latrine versus the smaller latrine and moving it from location to location, I take on board your security issues, very, very important. But could you give me a kind of a brief idea on the notion behind why you used the larger latrine rather than the smaller latrine, moving them? And I say this from a personal perspective, because I do remember moving my own grandfather's latrine around the garden in Roscommon, and it's always trying to find the best location, and also to make sure that we didn't put it in the location we'd used before. But aside from all of that, can you just give me some ideas on your thoughts behind the use of the larger latrine rather than the movable smaller latrines, apart from security?
Well, I suppose because often the mindset is to, or from what we discovered, the mindset is to build kind of more temporary latrines, which I think might be a little bit wasteful of resources. But also, if you build a large enough pit and a large enough latrine, it can become part of the design. It can become part of the development. It won't need to be moved. It can be used for decades and beyond, which I think is more efficient long term.
Excellent.
So yeah,
excellent.
And it has worked. It has worked, this idea. And I spoke with that architect that we got a chance to speak with, hopes that this kind of idea will continue and kind of change the mindset, and kind of address, I suppose, certain social issues that might happen.
Yeah, and Alan, this project as well, which I presume you largely carried out on your own. I mean, I just have to give you praise for the amount of work that you've put into it, and the amount of ideas that you've included in the design. It's excellent.
Brilliant. Thanks very much.
Thanks, Owen. Aravinda, Declan, any brief last comments or questions there before we move on?
Yeah, I had a small question. Thank you. Well done. Well presented, Alan. I had a question about the feasibility of construction in terms of local labor or local craftsmen building this concept. Have you considered that in your designs?
Yeah, it was quite a large part. So I mean, certainly I'm using timber trusses. The aim is to employ local carpenters and local craftspeople to create those on site. CSEB, so compressed stabilized earth bricks, they can be made on site by local craftspeople. Again, when you're using bamboo or woven wreath mats, that's all local skills. So yeah, I really I thought about that throughout my design, to employ people. Yeah.
And the second follow-up question to that would be, what have you considered in your design as a cultural aspect of this particular building? What is it from the local community which would stand out, which you say is a part of the cultural aspect of this building design?
Yeah, so in phase 2, I have a large open Insaka. So from the central courtyard, you move into the Insaka. The Insaka is a community space, and then you move out onto the vegetable garden. and that can all be used by the kids and the staff, but then, you know, by the wider community for all a manner of different reasons. So that's kind of how I address that. Yeah.
Got it. So I think the last one would be, so when you say wider community, is there something you're considered for the moms of the kids who would come into the school? Is there something they could do when they come to the school, leave their kids or wait for the kids?
Yeah, that's what I was thinking. You know, ceremonies, celebrations, adult learning, you know, cooking, just a variety of reasons. And also there's a water pump in that central courtyard next to the Insaka, and that's a meeting point, the water pump in Zambia. So it all kind of bounces off one another.
All right, excellent. Thank you.
Thank you.
Brilliant. Thanks very much, Alan. Just conscious of time there now. So if Declan, there's any other particular question you had?
No, I actually saw the presentation of this project before in the heats. So well done, Alan. It's an excellent scheme. I really like it. A lot of thought went into it.
Brilliant.
Thanks, Declan.
Thanks, Declan. Great stuff. Thanks again, Alan. Well done.
Thank you.
So we'll move on now to our third project, which is EduSoap. So that's Kevin, Owen, James, and Ellen, product design team from TU Dublin. So EduSoap aims to teach students the science behind soap making and educate them on the importance of hand washing. And the team's information booklet outlines the process of making black soap. So I will pass over to you there now, guys. You want to kick on?
I'll be presenting, and just to say, we'll be playing a video in a few minutes. So if anyone can't hear the audio or if it's lagging significantly, I can send a link to the YouTube video in the chat.
Great, thanks, Kevin. I'll confirm that.
Hello everyone, my name is Kevin Gilday. With me on my team today is Ellen Dack, Leah Perez, Owen Rowe, and James Toomey. We are EduSoap, and we plan to introduce soap making into the Zambian community. I'm going to play a short video now which will summarize our plans and our project. In Zambia today, 29% of Zambian deaths are caused by preventable infectious and parasitic diseases. Pneumonia and diarrhea, two leading causes of death, are directly linked to poor hand hygiene. Yet only 13% of Zambians have access to a hand washing station and a hand washing agent. Hand washing agents are not as common because people have not been educated on the importance of its use and don't value it in their household spending. However, a simple but effective soap can be made using only 3 ingredients: ash, which can be obtained from any fire for cooking or heat, water from either rain or taps, and oil, which is locally available and within household budgets. The process of making the soap is extremely easy. The ash, oil and water are mixed in a pot and placed over heat. While continually stirring, the ingredients will begin to emulsify and start to foam. After some time, the mixture will begin to smoke and eventually start to change colour. When the mixture reaches a dark brown colour and thick consistency, it can that freeze?
Just pause there now, Alan. Yeah. Oh, sorry, Kevin. Apologies.
Yeah, apologies for
Don't
this.
worry now. You can always share in the link if required.
Yeah. Let's see if this.
I think Kevin maybe just share the link, just because we're conscious of time here.
Yeah. Sorry, I'm gonna have to stop sharing for a second just so I can get the chat up. So I think we're about a minute in. If you want to click in, and then sorry, that was too direct.
Great, thanks, Kevin. Are you continuing on then, Kevin? Or
yeah, will we continue? Will we?
Yeah, absolutely. Yeah. Okay.
Perfect. Zambia today, 29% of Zambian deaths. So, 29% of all Zambian deaths can be attributed to infectious and parasitic diseases. A majority of these deaths are preventable deaths using just basic hand hygiene. Yet only 13% of people in Zambia have access to water and a hand washing agent for hand sanitization. This leads to a huge amount of health problems and also attributes to over half of all malnutrition cases in Zambia. Our solution is to introduce the making of African black soap into the Zambian community. African black soap can be made of only 3 ingredients: hardwood or plant ash, which is a byproduct and a waste product of all fires for heating or cooking, water, which is commonly available, and oil, which is widely available and cheap and available in all household budgets. Owen will go through the collection of a few of these ingredients.
So ash is definitely a core ingredient of soap, but we found through our research that not all ash is created equal. So for example, ash that's created through the burning of hardwood or dried plant leaves, such as cassava, is more rich in potassium, which makes for a better soap. And also very important when you're collecting your ash is to filter out large particulates, as the ash will actually end up in the final soap and you'd rather not have large chunks of carbon. Next, onto the water collection. So we found that rainwater is best, as dissolved minerals in tap water and groundwater can negatively affect the saponification process. So we propose really that it's just the best idea to either collect rainwater and store it until needed, or use any soap that's on, or any water that's on hand. And then finally, our ingredients. So our 4 ingredients really are hardwood, dried plant leaves, cooking oil, and water. And we tried to keep these as simple as possible so that be available to as many people as possible. And next we have our apparatus. So we have a vessel, a large metal pot that cannot be made of aluminium or copper, as the caustic solution later on would degrade these materials, and that's quite a negative. A heat source, we kept this very vague for the reason that anyone who could get their hands on the leaflet could make the soap. And then the stirring apparatus and the containers, we also kept very vague so that people with any amount of resources could take part. And then safety. We thought safety was a very big thing to buckle down on, because during the process, the mixture is caustic at some points, very hot at some points, and at some points also smoking. So we recommend the use of eye protection, hand protection, and both mouth and nose covering. Next is on to Ellen.
Hi, so I'm just going to explain the saponification process from a user perspective. So firstly, the user will have to warm the oil over a heat source. Then in a separate pot, as Owen said, not made out of aluminium or copper, they'll mix the ash and water together and dissolve it over heat. Then the oil is added to this ash solution, and it goes through a couple of different stages. So firstly, it emulsifies, then it begins to foam, and it begins to smoke. And as soon as it starts smoking, a color change and consistency change will happen. And this is an indicator that saponification has occurred. So then the soap needs to be cooled down, and it can be used after 2 days. As you can see here, this is the finished soap. It's very different to the soap that we're used to, particularly in its color, but also in its consistency. So it's not a solid bar soap or a liquid soap. It's kind of a semi-solid paste consistency. And as a result, you can move on there, Kevin. We've designed a soap holder to contain the soap. So this can be made out of any permeable textile. So it can be made out of t-shirts or socks or anything like that. Some string to sew it together, a needle to help with the sewing process, and then anything to cut the material into the desired shape. And you can see there's a really simple step-by-step on how to do it. Sorry, back there, Kevin. And we can see this being possibly implemented in schools in an arts and crafts class. Sorry. And then you can move on now, Kevin. The other reason that we designed this is so that it can be incorporated with systems which require bar soap to be hung on a string. For example, you can see it here incorporated with the Tippy Tappy system, which is used in Zambia at the moment. So it can just be hung in the bag, and it can be used through the bag because the material is permeable. So I'll pass you over to James now to talk about the education opportunity of our leaflet.
Yeah, so during initial research, we talked to people who worked in the education sector in Zambia. And what they told us was facilities such as science labs were massively underused due to a lack of resources and also finance. So we were considering how possibly the soap could be made in Zambia. And we decided that what would be best would be to maybe make soap in these facilities and get use from these facilities and resources. So what we created was a step-by-step map for a teacher, similar to what you'd have here in Ireland in primary schools with teaching plans. So it gives you prompts for the teacher to mention important factors and gives a real detailed guide through how it can all be made. In the next thing, which is our final product, which is the leaflet. And what the leaflet is intended for, it's a small pocket-sized leaflet that can fit in a school child's pocket. And it's aimed to be printed on an A3 piece of paper and folded along the designated fold lines. This leaflet comes with important information such as how to wash your hands correctly, the correct procedure, which we're all used to now because of COVID. Important statistical data on why it is important for this important to wash your hands and etc. And some science as well on the process. That's in simple language that the kids can clearly understand. And the goal of this is really to have something that kids can look at and maybe spur them into further education through looking at the science and getting interested in it. So in the inside of the covers, it's again kept quite simple, but the inside explains how soap is made, and this should be used in conjunction in the science lab, we hope initially. And it shows primarily through pictures and icons how the soap is made and with simple language where it needs to be. It also shows how to make the soap holder. We aim for this as well to be brought home, and hopefully at home, adults and parents will also be able to use it. So we have 3 sustainable goals. And what we'd like to do is educate the Zambian people about the importance of soap and provide them with the necessary skills to create soap from affordable materials, meaning that they will be able to continue to produce more soap indefinitely. And our 3 sustainable goals are to create good health, quality education, and clean water and sanitation. Thank you so much for listening, and if you have any questions, we'd be happy to answer.
Brilliant, thanks very much, guys. Well done. So yeah, pass on to the judges. Just to mention, guys, as well, Declan has had to leave now, so we'll just be going forward with our 4 judges. So whoever wants to jump in there maybe first, maybe Aravinda, to start with you this time, because I've been coming towards the end last time.
Thank you. Yeah, very interesting. It's a concept I'm familiar with, I would say, having lived in India, where we use soap made from ash. We also toothpaste from ash as well. So it was interesting to see that. My question was related to how much water you would need, because water is such a precious commodity. So have you gotten any thoughts about use of how much water would you need to use this kind of a soap, or have you thought of any other concepts related to that?
Yeah, so I think the water quantities were there. We did it in parts, so it was easy for people to measure without like a measuring jug or anything. Kevin, do you have the exact ratio?
Yeah.
I think it was 3.
So yeah, there's 3 parts water, 3 parts ash, and 2 parts oil, and that's by volume. So it's actually a really, really small amount of water is used to make the soap, and the majority of this water evaporates during the saponification process. And then while actually using it, you use the tippy top process, which is commonly used in Zambia. And the main reason for use of a tippy top is because of the tiny amount of water it takes to wash their hands. So yeah, the water needed to both make the soap and to use the soap, it's actually really, really small.
Excellent. And have you considered use of any other herbs during the soap making process along with ash?
So Owen considered that.
Yeah, so during experimentation, we tried some different types. So we tried adding lavender and a few different types of herbs to see if we could get any scents, and also lemon peels. And from our experiments, we couldn't get them to actually impart any extra scents. But I think through further development, maybe cooking the herbs with the actual soap could definitely have, or even using essential oils instead of actual dried herbs might have better impact on this kind of thing.
I think as well, so like any plants high in potassium will be beneficial to the soap because they help with the saponification process. So like if there were herbs that were high in that, then they would definitely work in it.
Got it. I think the last question I had was in terms of use of the soap. You had a concept of using the soap in a textile covering.
Mhm.
My question was more in terms, is that hygienic in the way it's being used?
We think so because it will be used with soap, and the soap itself will be antibacterial. So that was our thought process behind that. The soap can also be used like directly from a container. Our idea for that was based on the tippy tappy that required a bar soap, and then also it meant that students could carry the soap around on their person if they wanted to as well. And we just thought it was a nice other activity for the students to be involved in.
Wonderful. All right, thank you.
Thanks very much.
Great, thanks, Aravinda. Pradita, do you have any questions there for the guys?
Yeah, so I really love the concept again. Field Ready also have worked, with this supply soaps. But I wanted to ask, the African black soap is quite a new concept for me. This is the first time I'm hearing about it actually. Has it been tested? Because, people will be making it separately, in their premises. So would it be hygienic?
Would it be hygienic, the process of making it? Was that your question, Pradita? Yeah. Mm-hmm.
Sorry, go on, Ellen.
No, you can go.
Yeah, so the process of making it, or was it the process of,
basically, would it be up to a standard? Would it meet a standard? Yeah.
Yeah, so African black soap is quite common in a number of countries in Africa, but it hasn't really reached the Zambian community or the vast majority of Africa yet. It's quite in Western countries in America. It's actually becoming more popular as like a natural alternative to what we use now, which is more synthetic. It has been tested and it's currently being sold at a quite high markup in America as like a natural alternative, and it's shown to be very good at both antibacterial properties, but also very good for the skin and moisturizing.
Yeah.
Use it for moisturizing hair as well.
I think one thing, so when the ash reacts with the water, it creates potassium hydroxide, which is a disinfectant. So it's just like it's really related to the natural and traditional process of making soap, which has obviously been around for hundreds and hundreds of years. So it is a disinfectant. I'm not sure the exact testing that it's been under, probably not as much as Western soaps, but it definitely is hygienic for sure.
Thank you. And one last question. So you guys did say that you prepared a template for the school students, right? So that means students would be making it, and obviously you guys might want be training the teachers as well. But if the students are making it, just as a to be for the students to be safer, like how long would it take for this to be made, and all the safety factors, including all the safety factors, like
from start to finish to make the soap, like from the point, so you say you have all the materials, it's actually pretty fast process, like about 15 minutes. That's how long it took me to make it in my house. Obviously it will depend on like the size of the batch and stuff, and we would always the students would always be under teacher supervision as well when doing this, because obviously there are a few dangers there. But that's why we recommended the safety equipment in traditional communities. I think it's mainly in Ghana that they do this. They obviously don't use this safety equipment, but we wanted to make that very important, especially if it's going to be with children as well.
Yeah, okay, that does answer my questions. Thank you.
Thanks very much.
Thanks.
Great, thanks, Pradita. Anne,
yeah,
do you have any questions?
I think some of my questions were kind of covered. But it's great. I mean, it's actually the first time I heard of the soap, like Pradita, and it's really very interesting. In fact, I'm going to try it out myself now because it just took ashes out of the fireplace yesterday. So I wondered also what Aravinda said about using herbs, so that's an interesting thing, because I think for it to be widely popular, it would have to smell a little bit nicer possibly. So that would be something to look into. But also I'm wondering about the lathering effects and whether you considered, if you ever put soap in a little net bag, it actually lathers better. Does this soap lather well? And if a net bag would make it lather better, I think.
So the lathering of the soap depends on the water quality. So the more soft your water is, the better lather it will have. So that's why Owen was recommended to collect rainwater. But if you can use harder water, but you won't achieve the lather, but the soap will still work. So I haven't tested, like, I don't know if the bag makes it lather more or less. We hadn't like compared the two. That the soap that we had was lathering because we used soft water. But I know that that's the issue with soap making if you use hard water versus soft water.
Very good. And I like the idea. I love the idea that it's also, this is not just for local community to make their own soap, but also a learning tool, and that the children learn a sustainable tool for them going forward as well. So great project, and I've learned a lot from it. Thank you.
Thanks so much, Anne.
Yeah.
Great, thanks, Anne. And Owen, any last questions there that you want to ask the guys?
Not really, no. Just to say that I think we all became very aware of the washing your hands over the last 2 years. But I suppose really just one thing, and maybe Ellen can answer this. You were saying, Ellen, there that you made it at home. I know that you highlighted in your project the safety concerns that you had in relation to making it. When the caustic reaction occurred when you were making the soap in the home, could you just give me a little brief description of that? And then how are you going to get that message across to the people and the communities on the ground?
So
apart from the leaflet, of course.
Apart from the leaflet to let them know
that the leaflet, because I think you were right in highlighting the safety aspect of it. But could you just briefly explain how you dealt with that in your own home and how that can be translated then into a community such as Zambia?
So within my own home, I think the important thing is that you have like a big enough pot for the safety purposes, because it does foam up and you obviously don't want it to overflow, and that I think that would be possibly the most dangerous thing that could happen. Sorry, I can hear myself. And then in relation to letting them know this in Zambia, I think we had put a lot of focus into the leaflet mainly, but I suppose we could do Zoom calls or anything like that to explain the process to them, and it would really be the teacher's job then to let the students know exactly the science behind it that's happening. We've explained it briefly in the leaflet and explains it quite well, but it would be the role of the teacher then to take over and explain to the students exactly what's happening.
Great, thanks very much. Great product.
Thanks.
Great idea. Thank you.
Brilliant. Thanks so much.
Cheers.
Brilliant. Thanks very much, guys. Well done. So we're going to move on to our fourth presenter now. So yeah, whenever if you want to, great stuff.
Thanks very much.
Thanks, guys. So we'll move on now to Dominika Kuzniar. I hope I'm pronouncing your surname correctly, Dominika. Good stuff. So Dominika is our second student now joining us from Waterford IT. So on her project is the Greenbelt School. So Dominika's leading concept of her Chile Village school design is an oasis, something that provides refuge, relief, or pleasant contrast. And the intention was not only to create an environment which would satisfy biological and physiological needs, like thermal comfort and good lighting in a sustainable manner, but also to address the more intangible aspects of human nature. So I'll pass over to you there, Dominika.
Thanks very much. I'll just start sharing my screen there now. Perfect. I hope you can see it all well. So I'll start off just from the initial stages of the design. The key aspect I took from it, the main challenge was really to create a sustainable and site-specific design, which enhances a sense of pride and ownership within the local community. Also, the problem that was identified was really the excessive and strong solar gain and the intensive wet season, which could be taken advantage of. So in terms of the solution, it was to create a meandering curved surfaces and natural low-tech systems to create thermal comfort and collect the rainwater. So in order to bring these three aspects together, I came up with the concept of the oasis. So when one thinks of an oasis, it's something really associated with the senses of hearing, sight, and touch. So my main question was, how do I create a strong sense of place within this based on that concept. So the emphasis was really placed on the entire environment rather than just on the buildings alone. So it was really a school that accommodates both during and after school activities and gives something to the community. So as the concept developed here, as you can see, along with my research and knowledge gained about the site and the climatic conditions, also another aspect that was taken into account while developing the concept was really the local culture and beliefs. So for example, I read that the layout of traditional villages is really based on the idea that it's the chief's courtyard that's developed first, and then all the other members of the community gather around it. So really the oasis reflects that in a certain aspect of it, maybe not literally, but in a more metaphorical sense, let's say. So really I wanted to reflect that to create a sense of familiarity and not give something to the community that's strange and foreign and unknown. So in terms of the site and the climatic conditions, in order to address these things, certain aspects were taken into account. So first of all, the cooling and ventilation was inspired by the ancient Rome impluvium and compluvium, which serves to cool the surrounding area. So really the oasis, then hopefully the cooling effect will spread to the surrounding spaces. Also, the natural ventilation is aided by the orientation of the buildings, as the prevailing winds are southwesterly and northeasterly, depending on the season. So really these spaces here, because they're compressed and expand, hopefully the suction effect will help to push the wind and the air out to cool the spaces even further. And another thing, so the classroom, which at the first glance may seem quite unusual due to their circular shape, but there are a number of advantages to this. First of all, reducing the solar gain with the curved surfaces, material efficiency, as it's 25% more efficient than rectangular areas of the same area. It's more economic, and another aspect is it's more inclusive, and also really basing it on the vernacular architecture that's found in the area, creating that sense of familiarity once again. So another thing, so the whole site, I really wanted to reflect the whole environment. Really is the emphasis placed on the environment. So creating really an environment where kids can feel free to linger and really discover the site as they walk through the certain areas and certain zones within the site. Another key element was the spatial sequence and the visual connections while a child is, for example, in this playing area, where you can see here in this diagram, when you're in a particular place, you really have the visual connections to all the areas of the site, creating a sense of belonging at whichever space you're in within the whole site. So the emphasis is also placed on the children, was really the key element. So for example, instead of doing one large vegetable garden, I decided to go for multiple smaller areas which correspond to the classroom. So the kids, depending on whichever classroom they're based on, they have a corresponding garden, which will provide a sense of ownership and responsibility to the kids, and creating more of a connection with the site and the school. So in terms of the functions, here you can see are the teachers' accommodations. I decided to provide 2 different sizes, as one problem was the fact that teachers who had to travel from bigger villages, they actually they were found to be, calling in sick quite often because they didn't want to travel to these long distance areas. So I decided to provide 2 different sizes to accommodate both teachers who have a family and teachers who perhaps need a smaller sized accommodation. So I'll move on now. So the design really aims to enhance the environment by ensuring community participation and involvement from the early stages, making it an integrative process and embracing local skills such as weaving. So it's located at the crossroads near Health Centre, within a walking distance to the site. So I think the integration of the school has the potential to really enrich the site and the density in this low settled area. Design could be carried out in phases, giving priority to the classrooms, moving to the staff accommodation to entice teachers, as said already. And another thing was nature, creating green areas along the site and replanting trees and planting, for example, mango trees. So this here is the overall site, and that's a section there through the site. I'll just give a second so we can look at it. So now, so in terms of, so instead of viewing the local materials available as a limitation, I really decided to use this as an opportunity to integrate local craftsmanship skills and embracing local creativity and labor. So as I said before, the weaving mats, which create a more dynamic ceiling and fun ceiling within the classroom area. Another focus on was reducing the building life cycle impact on the site. So one element in order to employ that was, as termite mounds are quite a popular feature in Zambian landscape, I decided to use abandoned termite mounds to create a certain amount of CEB bricks. So really recycling and reusing materials that are there. And the project was also adapted to standard brick sizes to reduce any waste on the site during the construction process. So I think the approach to the project is a unique one, as the process is as important as the final outcome, meaning that the process aims to be inclusive and teach the local community new building techniques, and also creating an awareness of their local materials and skills, and really make advantage of them rather than seeing it as something worse than concrete blocks, as is often perceived between the locals. So another key area was the water, creating a closed loop system using low-tech solutions. So the site has the potential to become a place in which these systems could be taught to the locals, and hopefully the knowledge would spread once having gained momentum. So starting from collection of the rainwater, storing the water in tanks, perhaps if further needed to clean the water to use as drinking, filtration could be used using low-tech biofiltration methods, and the overflow could be then put into the small vegetable gardens, as can be seen in this section. So as said by Emma there previously, the school environment should firstly provide biological and physiological needs like thermal comfort. However, I think I also decided to address the more intangible aspects of human nature, and also focusing in a more anthropological sense, and also with harmony with nature, really putting the human and nature as one. So with the concept of the oasis which was placed within the meandering street, emphasis is placed on the human senses of touch, smell, sight, and hearing. Connection with nature is not only important for the well-being of human beings but also one feels protected and calm when surrounded by natural materials such as earth, plants, and the soothing sound of rain, for example. So another aspect was my investigation of the light, and how do I control the light within the environment, especially within the oasis. So the arrangement of the bricks and the voids follow and are adjusted, their angle is adjusted to control the sun intensity depending on their orientation in order to block or diffuse light. So for example, the morning gentle north sun would be allowed to enter into the oasis, as can be seen here in the graphic, but the south sun, the bricks would be put at such an angle to block the light and diffuse it, and just allow the diffused light into the space. Now in terms of the classroom, so the classroom, is really the main focal point, especially when considering the kids, as they were placed in the epicenter while making my design decisions. So the child's perspective and the manner of viewing the world was critical to consider. So based on the social learning theory, kids can learn, from simply observing other kids, and it doesn't have to, the learning experience doesn't have to be limited just to the classroom. So through interaction and observation, kids can learn as much, if not more. So as a result, I derived at a more socially sensitive design, spaces that invite the children to make it a place of their own and expressing themselves. So this threshold space here is acting as an extension of the classroom, which can easily be monitored, but which also allows the children to see what other classes are doing, as you know, the works would be presented here. And so you don't actually have to go within a classroom to see what the other classroom is doing. So it really is creating that sense of belonging and a sense of place as you're aware of what's going on within the school environment. And so the structure also is integrated within the space, and thermal comfort by, for example, even considering the details of the door, which allows the teacher to control the ventilation within the classroom. And then this are just some further few images. So yeah, that's all from me. Thank you very much for listening. That's all.
Brilliant. Thanks so much, Dominica. So guys, I'll pass on to you there. Maybe Owen, we haven't, I think, come to you first. So go in rotation if you have any questions there for Dominica.
Yep, just one. Again, Dominica, thank you very much. It's a great project. I'm fascinated by the different concepts from the architectural projects, and each one of them for us, fortunately, is different, and what you got has a different emphasis, and that for me is a learning experience. So it's great to see you exploring that as well. I suppose just in terms, back to the question I asked before on one of the previous projects in relation to the water and the harvesting of rainwater. The use of the harvested rainwater for me, I suppose, is a concept that I think that people should kind of try and really think a little bit more about. So I'm just wondering, on your design there, now you forgive me because the text is very small on my printout here, but it looks like you're producing 46.8 cubic meters from, it says there, is that per classroom or is that in total? And that you will use 5 to 10 tanks to collect that. And again, are you intending to use that for irrigation, for potable means, or for hand washing? That question there. And you could just briefly, I know my question is probably a bit long. And then the second question, and this comes from me being my structural engineering things, that you've also highlighted the use of 5 beams there in the design, and they're concrete beams. So I just want to know about the knowledge that the people on the ground may have about the design of concrete beams, and whether you're going to use reinforced steel, because they look like they could be members that are in tension rather than just in compression. So could you just guide me through that thought process in the design, those 2 elements, if you can? I know we're up against the clock, but that's basically my question.
Yeah. So in terms of the water, I see. So there are tanks placed outside of the classroom. So I see them as being used for the gardens and irrigation, and the kitchen really using it for the toilets as well. But then in the place of the oasis, I think that has the potential of really being used as potable water. Once certain systems are put in place, hopefully, or I think even the rainwater itself, using the first flush system, I think that could be more than enough as well to ensure that that's safe to drink. And your other question about the structure. So yeah, in terms of the beam.
Beams, concrete beams.
Yeah, I think, so as I said as well, I would like the process to be as important as well for the local community. So perhaps I see that as a potential to teach them, new techniques of building and the potential of it. But the trusses themselves, I intend to use wood and then hopefully reinforced concrete beams for the other construction.
Thank you very much. Thank you again for a great project. Really wonderful. Yeah, thank you.
Thanks, Owen. Anne, do you have any questions there for Dominica?
So that was really interesting, Dominica. And what I love the whole idea of the circular buildings, just to reflect what is the practice locally, and the idea of you really watching where the light is going to be at different times of the day. You've really thought about that. I think it would be such a lovely, welcoming, really, really pleasant place for children to be. I'm just wondering, like it seems to be a new site, is it? Have you envisaged this as a new site, which, and why is that? Or, you know, this doesn't seem to incorporate an old school building. So
actually, one of the building, I can actually share the screen there again, but one of the buildings is actually, I repurposed the existing building on the site, is integrated. It's acting as a science lab, and it's also divided for the student accommodation for female and boys. So one of the buildings is actually repurposed. It's the existing building on the site.
Okay, very good. Sorry, I missed that. So I'm sorry about that.
That's no problem.
And then just we won't spend too much time talking about toilet blocks, but have you thought about new toilet blocks also? Because I only see a couple of toilets mentioned on the plan, but again, I've probably missed that. So
yeah, so it'll be hopefully, you know, pit toilets, and hopefully with the intention of using potential as compost for on the site, but they are there. So yeah.
Great.
Yeah, thank you.
Thanks, Dominica. Pradita, do you have any questions there for Dominica?
Yes, a few. Well, I really love the concept, Dominica, and I really, you know, enjoyed like thinking about the perceptions that you've got, your attention to the details with all the lights, the, you know, the filtrations, the vibes, the, you know, everything. So I really love that thing about your presentation, your concept. And I really, you know, I really liked that when you said that, you know, the materials are also available, you know, well, it's wonderful as a whole. The only question that I have, it's like in the earlier, when you started, you did mention about, saying that, you know, I think you were talking about the semicircular blocks, that the 25%, you know, it's 25% more efficient than the rectangular ones. Could you elaborate on that, please?
Yeah, so an important factor was really trying to reduce the materials used on the site. And from my reading and my research, I did read that, you know, circular buildings use, you know, quite a substantial less amount of materials than, you know, a rectangular shape for the same, you know, area and meter squared. So I thought that was, you know, is definitely a positive impact. And if not only, you know, also the people, the local people, they have knowledge of construction of circular forms. So I think even if something requires to be fixed, I think it's much easier for the local people to fix that rather than, you know, trying to take an external person with, you know, with the knowledge to fix the roof, for example, or other areas. So I think that was another key aspect for me, was really trying to see what's locally available, what's the knowledge available as well, but also trying to imply an innovative aspect to it to teach them something new as well.
Brilliant. Is that, you didn't have any other questions there, Pradita? No? She seems very focused. I think so. I'm not sure if she's frozen. Anyway, we shall move on. Aravinda, did you have any questions there?
None from my side. I think I was in the judging ceremony for Dominica and team there, so no questions from my side.
Okay, brilliant. Great stuff. Then, guys, we will take a break now. Yeah, before we move to our final 4 students. So I think we're going to be grand for time. I won't reduce the break because we all like to have our breaks from screen. So, but if we're all back for quarter to 1, and we will start then. So yeah, any questions or anything, guys, just pop them in the chat, but otherwise we'll see you then, and we'll start promptly at 1:45. Okay, thanks, guys. Hey, Pradita. Do we have everyone back there now? Checking in. Yeah, cool. Good stuff. We've got all our judges with us. Yeah, excellent. Okay, brilliant. Then we'll kick off. So we're moving now to our second product design team, H2Go team, which is Rebecca McGrory. So the H2Go team have created an interactive water purifying kit consisting of a booklet that teaches children how to purify their water by utilizing waste materials such as plastic bottles, aluminium cans, plastic bags, and charcoal. So Rebecca, I will pass over to you there.
Yeah, just setting this up.
Cool, yeah.
You should all be able to see that.
Yeah, you can indeed, yeah.
Perfect.
Hi, sorry. Can people hear me by any chance? I can't hear the audio.
Yeah, you're good.
We can, yeah. All good, Sophie, yeah.
Okay, perfect. Sorry, I'm having some audio issues, but I'll continue as long as everybody can hear me. That's good. Okay, so I would like to introduce our project. So good afternoon, everyone. My name is Sophie, and my teammates are Deepa, Aisling, Magda, and Rebecca. And I would like to introduce our project, which is H2Go, an educational kit based at educating children about water filtration. So I will now play a short video on our project.
Today, education is one of the most important resources available to children, giving them the opportunity to excel and setting them up for the future. Unfortunately, many children are forced to leave school prematurely, in many cases due to the lack of access to clean water. The equipment and materials needed to run science lessons within schools is also underfunded. We decided to tackle both problems and create H2Go, a kit that allows teachers to run science lessons with reusable waste materials and basic stationary equipment. This booklet teaches the importance of clean water, the process of the water cycle, and how water filtering works. The booklet also provides a practical scientific experiment by showing an example method of building a water filter and collecting the filtered results. The goal is to filter the most water within a few days, which the inspired children can create versions of before analysing to determine the most effective variables in their designs. This will be conducted through a friendly competition which can be displayed on the poster leaderboard. The example water filter works by evaporating dirty water to remove contaminants and condensing the resulting water into a charcoal filter. The charcoal then removes the colour and taste, resulting in clean, fresh water. This kit will contain booklets, scissors, tape, pencils and string, depending on the class size. The water filters can also be made using common waste materials like water bottles, cans, buckets, plastic bags and even clay. By giving the children freedom over designing their water filter, we hope to inspire creativity and encourage them to use their imagination while teaching them the scientific method that they can use in the future. Now, H2Go, make your own.
So when beginning our research, we discovered that 64% of Zambians have access to basic drinking water. When researching education, we found that only 43% of children in Zambia attend secondary school. And according to UNICEF, in Zambian schools, lack of access to adequate water supply, sanitation, and washing facilities negatively affects students and contributes to high dropout rates in school, especially among young girls. So what is the solution? Our educational kit aims to tackle this problem by educating children on the process of building and testing a water filter using common waste materials, such as plastic bottles and containers. We hope to improve the science lessons taught in these schools and allow them to build a better home with community-based filter system within these schools. So when we were looking into our research, we found that Zambia has quite a high level of pollution in the water, particularly plastic pollution. So this would include plastic bags, plastic containers, plastic bottles, and it's an issue that seems very pertinent to the country at the moment. In terms of clay, we found it's a very common resource used for crafting eating utensils and containers, and it's quite commonly used in Zambia also. We also found that charcoal is a readily available resource. Pure carbon can be made with wood or most other plant materials also, while limiting the supply of oxygen.
So while charcoal is a readily available resource in Zambia, we had to make our own. We did this by burning wood inside of cans in an oxygen-deprived environment. Once we had done this, we used this charcoal to create water filters. We tested filters both with and without charcoal and found that the addition of charcoal helped to improve the clarity of the water, the taste, and the smell. From our research, we know that the charcoal also helps to remove toxins in the water. We went on to develop different concepts using charcoal and evaporation. We tested a variety of concepts and learned a lot along the way. We decided that the best intervention we could make would be to design a simple experiment and an educational booklet that would teach children about how to filter water, the scientific experiment, and hopefully in the future encourage them to use this knowledge to build their own filtration systems in their homes and communities.
So the H2Go booklet was developed to assist teachers and students with the creation of water filtration systems when teaching science lessons, while providing a method of tracking and comparing results of experiments undertaken. The booklet consists of simple instructions based on universal imagery to be accessible and as easily translatable as possible. And the booklet itself describes the steps undertaken to carry out the H2Go filtration method. And the method consists of utilizing common waste materials to purify water by evaporation and condensation, drawing inspiration from the Earth's water cycle. This was incorporated to educate children about the water cycle itself while explaining the difference between water filtration and purification.
So in terms of the kit itself, we wanted to include everything that the students would need to do this experiment, apart from the materials for the actual water filter. So not only are we including the booklets that include all the information, we're including a poster where they can record their results, pencils, scissors, tape, and string. And these all help to create better water filters. In terms of an actual lesson involving these booklets, the booklets will be handed out to the class, and the class will be divided into groups. They'll talk about what's included in the booklet and the different types of filtering water and what they're learning through it. They'll then create their own designs using waste materials, so they'll create their own actual water filters. These water filters are then left out in the sun for a couple of days, and the clean water that's being filtered is then measured. These results are then put into a chart, and at the end of the week, the group that has filtered the most water wins. The group will then discuss what makes this particular design successful. It could be leaving it in the sun for longer, it could be the size of the bottles, it could be the materials used. And this all helps them to then, in the future, build better water filters. The reason that we're using this experiment, it requires very little materials. There's nothing specialist that they need to go and get. They can source it all themselves. It's very easy to teach children. It's fun, it's interactive. It's also developmentally appropriate for them. It's educational. We're not only teaching them the water cycle and why we use filtered water, but we're actually teaching them how to run a scientific experiment and then how to learn from the results of that experiment. It also has several real-world applications. These kids can then go home, they can build a community or a water filter for themselves, and then in the future they could build a larger scale community water filter because they understand the concepts of water filtering.
With regard to sourcing, we plan to reach out to local printers such as ProPrint Limited and Printfast Zambia, who can produce an A2 poster and a 7-page teaching booklet with a glossy finish. We hope to get branding stickers done in place of personalized boxes if they're unavailable. And once that's compiled, we can allow for either teachers or volunteers to inform us of class sizes and the equipment requirements for assembling the kits before sending them out. To ensure that there's enough raw materials for the experiments, we hope to source waste materials from Lusaka, where we hope the whole manufacture, assembly, and distribution operation is carried out, reaching the entire nation. For the future, we plan to evolve the design and competition through end-user testing. This will not cost much more than a simple file change and reprint. And if successful, a brand may expand to other lessons, such as construction with pulleys or levers, or first aid to offer real-world applicable skills that the H2Go kit represents. With this in mind, it shouldn't be difficult to distribute the kit where it's needed in the relevant language. Thank you for listening, and we look forward to answering your questions if you have any.
Brilliant. Thanks very much, guys. Well done. So yeah, whoever wants to jump in there. Pradita, I see you there on screen if you have any questions for the guys.
Yes, just one question. Yeah, it's something that we've all learned in school, and I really, kind of found it really interesting, like how you've made it as a package, and that the students can learn from it. Basically, with all the stepwise process and everything. The only thing I wanted to ask was, have you guys tried it? You know, like how long would it take? I'm not sure. Like how long would it take to, let's say, get a purified water? If How do I like if just how do you measure it? Like not how do I ask this question? I don't know if I'm able to make
yeah. How long will it take to get results? Is it? Yeah, so this is all depending on the sun outside. So what happens is the sun shines on the bottles, it creates heat and it evaporates the water, and then it all condenses through that. So depending on the sun outside will depend on the amount of water that they get. We did run prototypes, and in the Irish sun in the middle of winter, we were actually able to get water out of it. So I would imagine in a hotter climate with more sun, they would be much more successful, and they'd be able to get measurable results.
Yeah, as I was, about to ask this question, I then realized that, you are in Ireland. So yeah, but then so thinking about that, like, making it usable for families, how, it was just, I was just curious about it, like, how much time would it take for, for a bottle of water to get filled in that way? It was just, I was just curious about it.
Yeah, no, I got you.
Again, it would.
Yeah, we're trying to teach the concepts. So we're not saying that somebody's going to bring home this bottle and this particular bottle is going to, provide clean water for their whole family forever. What we're doing is teaching them the skills, and then they go home and then they apply that to a larger scale prototype, or they use a different concept. We're teaching them not only the process of it, but also how to understand that, this other group, they managed to filter more water. That design was better. So we need to take parts of that design to incorporate into ours, and then all of the designs become better. And then through this kind of process of testing and iterating, they come up with better products.
So while presenting, you were also saying that you were checking the quality of the water. Like how were you checking it? Was there any equipment that you were using, or how were you doing that? That's my second question.
So we were looking into having different test strips, but we found that we don't really want to be sending that out as such a consumable resource. So we decided to use a color chart instead to give a general identification, but overall purity, when it's brought to a larger scale, we'll have to develop that further.
Okay. So, but then the color chart, it's included in the kit?
Yeah, along with a ruler in case they don't have one accessible. It's all printed inside the booklet.
Okay. Thank you so much.
No problem.
No, I was muted. Thanks, Pradita. It always happens at least once in one of these sessions. And do you have any questions there for the guys?
Yeah, I love this idea, and as Pradita said, it is something that I do remember from the science class myself. I wondered whether you had talked to any Zambian teachers just yet. I know that they're definitely going to be involved in data collection, because you're going to send out kits and then you're going to try and improve on it. But like, have you talked to any to see how this fits into curriculum? Like because that it'll be very much whether it fits curriculum and whether they'll use it. I imagine it does, because it's quite a common kind of a test, but that's just my first question, whether you have talked to any Zambian teachers yet.
Yeah, so we haven't had direct contact with teachers as of yet, but we did learn through that there are a lot of science labs that are underutilized because they don't have equipment to run a lot of experiments. So that's part of why we wanted to make something really simple with very little materials that they were easily able to source to make use of these. Some of the schools do have the laboratories, just not the equipment.
So that was kind of where the concept came from, was learning this. But yeah, we would need to speak to more teachers. We haven't had direct contact really.
Okay, thank you. And just my other question, I'm interested in your submission. You mentioned that this project was partly inspired by meeting with Barefoot Theatre Company, and I'm just interested to tell me how did you meet up with them? Because actually one of the facilitators in the Irish Aid Centre who I work with, he's a member, or was a member, of the Barefoot Theatre Company. He's from Zambia, so I'd be interested to tell him about your inspiration.
Yeah, we had a meeting through school. So our school kind of set up a direct conversation with Barefoot Theatre. So we were able to actually speak with them. And that was a really important part of our process, because we wanted to make sure that this was actually something that they could use and make sure that we were covering relevant topics. So the discussions we had with them were very, very helpful, and they were taken on board. So we're very grateful that we were able to meet with them the way that we were. It was very beneficial.
Okay, thanks very much.
Brilliant, thanks guys, thanks Anne. Aravinda, do you have any questions there?
Yeah, I think overall comments, they say water is the new oil. So water is very valuable. So it's a wonderful project. Might look very small in that sense, but it's a very valuable project. So well done, team. I had a question on the taste of water. So when you do this project, the water you get, have you tested out any kind of tasting or taste or odors which might be in the water which makes it drinkable, not drinkable?
I ran the water experiments. So that was our main reason for incorporating charcoal, was that even though we were doing this evaporation process, we could never get the water completely clean. So by adding the charcoal in, and it's a widely available material, we were able to take a lot of that taste and that smell out of it that we were experiencing. So by adding the charcoal in, most of that taste and smell goes away. It definitely absorbs all of those impurities in the water.
Got it. Okay. And a second question I had was, have you considered any mosquito infestations to the water which is lying in these bottles? Any thoughts given to that, being the fact that it's in Zambia?
That's something we would need to do a little bit of testing on. We're obviously using Irish water because we don't have access to anything else. But this will be one thing that's really good about this experiment, is that we can actually evolve it quite quickly. So we can send out a bunch of test kits. We can do tests with a couple of classes. We can get feedback, and then we can change it quite quickly and be able to distribute new kits that are improved and work with the class curriculums very, very quickly.
Wonderful. Yeah, I think I like the idea of teaching kids to make clean potable water. It's a very powerful concept. So thank you.
Thank you.
Brilliant. And Owen there, if you want to come in.
Just reflecting the comments there of the other judges, excellent project. I suppose really a couple of questions I asked in some of the previous one was the idea of converting the collected water into potable water, and the filtration processes. Like, I mean, it's essential. It's really a major team in all of this. So in that sense, it's great. I particularly like the idea of the competition in the school for the children to see who can produce the most amount of water. I think that would be a winner, that's for definite. But just in terms of the technicalities then as well, did you carry out much research into the difference between just carbon filtration versus the evaporation and carbon filtration, and what were the results there? And then the only other concern I had then, just as I did with the caustic reaction in the previous, was the cleansing of the receptacles as well. So like, what information can you give me on that? Those two items, please. That's it. Thank you very much again.
Yeah. So our first round of experiments with our creating prototypes and water filters, we ran them as separate. So we ran a set of evaporation and we ran a set of filtering experiments. And what we found was that evaporation would get the water mostly clean, and it would take most of the color out and most of the impurities out, but we could never get it 100% of the way in one go. And it was the same with the charcoal filters, that we would have to run the water through 3 or 4 times before we were getting clean water. So we found that by combining the two, the evaporation would get the water most of the way there, and then the charcoal would remove the final impurities and the final taste and smell of the water to get it completely clean. So by combining the two processes, we were able to speed up the amount of water that could be filtered in a certain amount of time. In terms of, sorry, what was the second part of that question?
Oh, and if you just want to remind the second question that you had.
Yeah, no, just in terms of the measured difference in the quality then produced by the two different processes, that's it.
Okay. Yeah, so the evaporation was much quicker, but we could never get it completely clean. And then the charcoal filter, we could get it completely clean, but it took an awful lot longer. So by combining the two, we were able to get completely clean water much quicker.
Thank you. That's it.
Brilliant. Thanks very much, guys. Well done. So yeah, thanks a million. And we'll move on now to Elena Stats from Waterford IT, our third architecture presenter today. So Elena's project is the Butterfly School, and she'll present a playful yet pragmatic design approach for a school complex which responds to the social, economic and climatic problems presented in a responsible and sustainable manner. So Elena, over to you.
Hi guys. Can you see my screen there?
Yeah, we can indeed, Elena. Yeah, all good.
Perfect. Yeah, so as Emma just said there, my name is Elena Stotts. I'm a third year architecture student at WIT. So as you can see in the title there, my school design is called the Butterfly School. Hopefully you'll find out why in a second. So the Butterfly School, as Emma said, was a design approach developed on a four-pillar framework, or as I call it, a design narrative. Those pillars being number one, an open learning landscape, number two, generosity and community, number three, sustainability, and number four, context and the history. So the history of the site and the people. So just a brief introduction before I get started. The scheme focuses more closely on the modular classroom unit, which are designed to be replicated, rather than on the school scheme as a whole, considering the classroom is the heart of any school, although obviously still great attention was paid to the school as a whole. The classroom responds to the climate and surrounding environment in an efficient, practical and sustainable way. The scheme's intangible qualities are reflected in the architecture. So a rational yet rhythmic, pragmatic yet playful design. So as you can see here, my design narrative. So just to go through what that means. The open learning environment is a place to learn, grow and play, and it incorporates obviously the classroom and the wider context of the site. So this shift from the educational technique was reflected in the modular classroom units. This technique obviously is a move from teacher-centered learning to student-centered learning. The classrooms were designed to provide internal areas for group work, a reading space for personal learning, development, as well as focused teacher-centered learning, and external semi-private garden space to accommodate learning through play and growth. So each classroom has its own little garden space. It's kind of more secluded and it's roofed. So the classroom garden is a primary purpose for providing outdoor learning space, however, also acts as both a shaded and covered play space in the dry and rainy season. So then in terms of the site, this idea of openness was incorporated into the actual design of the site as well. So when I go through later, you can see the spatial organization and how the site is kind of closed from one side, but opens out to the other side. So then the second pillar is generosity. So this means the design gives back to the community through creation of employment and the development of skills and construction techniques. So the school was designed with the intention of being able to give back to the community through the combination of local materials and techniques and new construction innovations. The school will be able to provide employment both through construction and maintenance, and obviously teachers then as well, and staff. The development of skills so that one might use the skills learned from school's construction to seek employment thereafter. So that's kind of bricklaying, timber work, that kind of thing. The design itself includes a new communal pavilion that also provides a mutual gathering space for the community. So this is also how it gives back to the community. And then the third pillar is sustainability. So that's minimizing environmental impacts through the use of local and sustainable materials and methods. I'll get more into that when I come to the actual classroom design. And then the context. So as you can see here in the site design, it's quite rational, but then you come to these units at the end where the accommodation, both student and teacher, is housed. And so these round structures mimic the existing vernacular structures in Zambia. So then just the school is entered from the south with the secondary entrance located on the west. One of the first pillars of design narrative can be seen on the primary approach to the school. So this is the community pavilion, the kind of meeting place, and it's also the location of the water pump. This building also houses a library and administration. On the right, then we see a bike storage and a medical center. And then if we follow that axis that way, then you can see the modular classroom units. So then if we continue with this north-south axis up here, we get to the existing school building, which will be converted into a science laboratory and the skills development workshop. So that's also how it gives back to the community. It's kind of like a third level way of learning that will be provided within the school. So after school, you might be able to attend skill learning workshops. And then on the right here, we have the dining pavilion and the kitchen, which can also double as an assembly hall, the dining pavilion can, and the vegetable garden up here. So then we have just classrooms, latrines. Up here is the student accommodation, and then kind of more private over here is the accommodation for teachers. So then this is just a section of the site that cuts through these buildings here. So then we have, up here we have the site analysis. So it's kind of a normal thing for us to do when we start off designing. So this, you can see the main circulation path to the site. I didn't want to change this too much. I want to keep it as natural as possible. And then the winds, you can see the north and northwest and east and southeast. And then the sun path, obviously then as well. So the layout of the site itself is designed off this kind of axial organization. So north, south and west, east. And this imitates the already existing circulation path on site. So then, as I spoke about earlier, the counterpoints at the end of each axis take the form of the traditional round structures that are found in the area. And it kind of makes these areas more secure, because I'm still trying to go for this idea of an open school landscape. But of course, then when you're talking about accommodation, you would prefer that to be more secure. So that's the idea of these round structures up here. And then this axis would actually act as a barrier from the outdoor play area of the school. So it kind of protects the children in a way. So then when we were going through our design, we were told that it was very important that the school would be functional in each phase of its development. So which is why I decided to make one structural system that would work for all of the buildings. So you can see here in phase one, the community pavilion is built, but the size and dimensions of the community pavilion can actually double as additional classrooms until the rest of the scheme is built, and so on. All the latrines and everything like that, the community pavilion, the dining pavilion, kitchen, they're all based on this same structural system, which we'll get to now. So this is a detailed section of the classroom. So this gray area here, you can see the internal space of the classroom. And then this here is what I was talking about, the open learning environment. So that's an outdoor learning space. So then just kind of the more technical side of it, the roof build-up is a metal corrugated roof with timber purlins. We thought that if you come down here to the design response, one of the important things that one of our mentors brought up was that it was quite hard to actually concentrate in the classroom when during the rainy season. So I brought in this idea of wood chippings, which would be used combined with local thatch and they would provide sound insulation on the roof, for the roof. And then we have it's just a timber structural system, locally sourced sustainable timber. And then the classroom is obviously, the roof is raised up, but local woven textile fabric is used to allow light in, but obviously no bugs and stuff then. And then this primary structure of the butterfly roof, I was talking about the butterfly school, is this large cast in situ concrete gutter, which supports the roof. And it's supported on either side by concrete walls as well. But the remainder of the walls is a compressed earth brick. And then up here we have the ring beam, timber shuttered windows, no glass is used. And then we come down here, we have the design response. So rainwater is collected into this large concrete gutter. And there's an overflow tank at either end to store the rainwater that's collected. The idea behind this is that so that when you enter the classroom, there's a tap so that you would wash your hands before you go into the classroom. And that obviously is for sanitary reasons. But you can also drink this rainwater, because rainwater is like one of the highest quality waters you can get. So the classrooms are orientated so that no matter what direction the wind is blowing, because obviously the wind changes in the seasons, that you get this natural cross ventilation, and then the raised butterfly roof lets the hot air out. And then the shallow pitch of the roof also protects from the strong equatorial sun. So then this is just let's zoom in here a little bit. This is just an axonometric projection, an exploded axonometric projection of the structure. So you can see how all the elements work together. And then down here, these are elevations of the classroom, and this is a plan of the classroom, so you can see how the classroom works. The group space, the reading space, and then the semi-private external space. And then these are just some models. And that's it, really.
Brilliant. Thanks very much, Lena. Yeah, so maybe we'll start with Aravinda there, if you have any comments or more questions.
Yeah, thank you. So I had a question here. In terms of maintenance of these corrugated roofs, what ideas have you thought of? Because based on the height and how the roofs are placed here and the structure itself, what have you thought about maintenance of these structures?
Well, we had considered, a lot of us considered using steel trusses, which can obviously be made off-site and then are brought on-site. But the idea behind the timber roof trusses is that it would be a lot more maintainable, especially because like carpentry and things like that are skills that the local people would already have, as opposed to metalwork. And things like metalwork, you'd need electricity and stuff for welding and that kind of thing. So that was the idea behind the timber roof structures.
All right. Also, in terms of heating, there's a tendency for these structures to become very hot. Have you considered how to keep the overall environment more habitable?
Yeah, so the compressed clay earth brick is actually naturally passive. So obviously then when it's hot outside, it's cooler inside, and when it's not that it gets cooler outside, but that's kind of, and then the natural ventilation system, the large shutters would let cold air cross ventilate through the space, and then the hot air would obviously rise out the top, and then the textile fabric is there so that the air can be released to the roof.
Excellent. Nice presentation. Back to you, Emma.
Great stuff. Thanks very much, Aravinda. Pradita, do you have any comments or questions there for Lena?
It was a nice presentation. Just one question now. You mentioned about the textile fabric. Could you elaborate on that? Like, what kind of fabrics would you use? Because it would be for thermal threads, right? So where did you end up, seeing that?
Your volume's just a little bit low there, Pradita, but I think, yeah, we got the question. You were wondering about the textiles, Elena, if
what kind of textiles they were, was it?
Yeah, for exactly, yeah, what textiles, yeah.
Well, it's actually quite interpretive, so I was thinking you could maybe bring more color into the classroom and use existing fabrics, colorful traditional African fabrics, or you could use things like their woven mats that they use. Even you can go as far as using bush poles and things like that if you want to kind of weave the material in between. So it's quite interpretive. It's but yeah, but to be traditional textile mats that they would use.
Yeah, thank you.
Sorry, great. Thanks, Pradita. And any questions or comments there?
Yeah, that was just very comprehensive indeed. Thinking of the sun path, thinking of the wind, thinking of gathering rainwater, thinking of sound insulation against that rainwater when it's banging down on the roof. I thought that you've thought of so many things. And first I thought of, like, Zambia itself is said to be shaped like giant butterfly wings. So you could tie that into your name somehow. The Zambia itself is meant to be, you know, when you look at it on the map, it's like giant butterfly wings. I was just thinking, yeah, this would be a beautiful environment for children. And you did say, you know, that you thought this could be a move away from teacher-centered learning to child-centered, but that would be a larger curriculum change, perhaps.
Yeah.
Is that something that you've thought about, whether this would be acceptable just yet, or maybe that's the way? Maybe Zambia is having plenty of curricular changes, and that's the way that suits it. The way our own here in Ireland, our curriculum is changing to be more child-centered. Did you look into that?
Yeah, I did do some research into it. It was quite hard to, as you said, implement a new curriculum. It would be more so kind of the idea behind the group-centered learning and that kind of thing, and the move away from kind of every student facing a blackboard and listening to a teacher all day, that kind of thing. So it'd be more interactive in that sense. Obviously, limited resources, so things would be difficult. If you wanted to use technology and things like that, it'd be quite hard. But yeah, like I implemented a science laboratory. That was something that they thought was quite a strong thing that was needed. And there was a library as well. So, but other than that, it's quite hard to kind of implement new curriculums and things like that as well, given the context of the site.
Yeah, I mean, it could be that there is a new curriculum at the moment or being in development. It's quite possible, and it's just something this would fit perfectly then if there was. Yeah, very great presentation. Thanks, Elena.
Thank you.
Thanks, Anne. Owen, any other questions or comments?
Yep, fantastic, Elena. God, I'm really impressed with the standard of the work coming from the architectural students there, in the sense that for third year students, and the presentation skills are just, I tell you, they're outstanding, absolutely outstanding. You must bear in mind as well, Elena, that I'm viewing this from an engineering perspective, I suppose, and an implication perspective, right? So in that sense, again, I'll go back to the basic questions about the cost, the implementation of the project on the ground, and you know, particularly the gathering of the rainwater. The rainwater, this roof here, you know, in terms of its complexity, it isn't simple. It is a huge roof, yes, and you know, it has the potential to collect an awful lot of water, particularly during the rainy season. Could you just give me an indication of the volumes of water you intend to collect here, and because of the size of the roof for a start, and also what costs have you done a costing analysis on the structure again?
So I haven't done, I'll be honest with you, I haven't done a cost analysis on the structure. But the rainwater collection, it's about 120,000 litres per classroom. That's the square meters timed by the annual participation. Or litres, sorry, 120,000 litres.
Excellent, yeah, that's great. Thank you very much. Again, a fantastic concept and fantastic presentation. And
thank you.
If we had strong, I suppose, ideas on the costing of the projects as well, it would be a real plus. But I'm really impressed by the standard. It's tremendous. Yeah.
Thank you. Great stuff. Thanks. Yeah, thanks a million, Elena, and well done. So we'll move on now to our second last group, who are engineers from Trinity, so our last engineering group, the carbon filter team with Una Cotter, Anna Woodcock and Oliver Begley. So the carbon filter team have designed a carbon filter that can easily be attached to any pump, filtering out the lead contaminants of the water, and lead contamination is a huge problem in Zambia. Utilizing the inexpensive and effective properties of activated carbon. The filter is a very accessible solution to this problem. So guys, I'll pass over to you there now, and your 10 minutes. Yeah, thanks. Oh, guys, we don't hear anyone there now if someone's meant to be speaking.
Yeah, you can hear me now?
Cool. Yeah, we can now, great. Yeah.
Okay, hi guys, my name is Oliver, and along with my team today we're going to be introducing our product, which is a carbon filter. So our solution is focusing on the Kabwe region, and more specifically the Sablé Nua town, just located outside Kabwe. And I suppose in this region from the early 1900s, there was huge levels of lead and zinc deposits discovered. And basically they're exploited all to the 1900s until about 1994, where they were shut down. And when the companies left the region, there was no extensive cleanup, and did not close the mines properly. So today you're seeing huge levels of zinc and lead entering the water table. And from the water table, that's where the town sources the majority of its water. So you're seeing huge amounts of lead and zinc reaching the end consumers, such as young adults and kids. And when you have extensive levels of lead and zinc in the water, it creates cognitive issues amongst kids and really affects organs. So it's a major problem in Kabwe, the world's most polluted town. And we thought it's the most prevalent issue that needs to be overcome. So in terms of our solution, filtration is the most viable solution to remove the lead and zinc. However, other processes such as reverse osmosis was a viable option, but it's very expensive, and a lot of water is wasted in the process. In terms of distillation, it's not very effective for large-scale solutions, and we're going to focus on a school, so it will not suit the needs. And finally, filtration. As I mentioned, we're going with this process, and it has to be done correctly, and we're going to use carbon in our solution, as a lot of the other filtration processes do not remove 100% of the metals. So as I mentioned, our solution is a small device that water is sent at the inlet from a pump and passes through our little box device where carbon is inserted and leaves at the outlet to the end consumer. Activated carbon was chosen and is the most effective in removing the large portion of heavy metals that are found in the water in the Kabwe region.
Okay, so I'm going to talk about how it works. The way our filter works is that there's going to be a bed of activated carbon inside the container that removes the contaminants and the impurities from the water via a process called absorption, where the impurities become trapped inside the porous structure of the activated carbon in little gaps and holes, as you can see in the diagram there on the right. And the carbon then will collect all of this impurities, and after a while will become saturated, and then will have to be replaced with fresh carbon then to continue filtrating. In the diagram there on the bottom, then you can also see a mesh in the filter. That there is to keep the carbon inside the box and let water flow through and out. So Oliver, you can move on there, please. One back. Thanks. So the design of our filter then is very simple. Minimalistic design of the filter allows for easy to use and understandable mechanism, and it adds very little complexity to what the locals are already familiar with, as it just attaches directly to whatever water pump they are using, thanks to our adjustable pipe connector. And Oliver, you can move on, thanks. And the materials of our filter are the adjustable pipe connector is plastic with a steel silver binding. The filter container itself is plastic as well. The filter material is activated carbon, which we found a company in Zambia that can source it. The mesh is then cloth, which can be sourced from Kabwe, and then the hose is going to be vinyl. We hope that in the future that the materials for the box and for the adjustable pipe connector will be changed and adapted to what is available in Kabwe itself, as the design is quite simple, that we hope that the community will be able to make their own containers as we move forward with this design. The cost and performance. So the initial cost is 24.39. The adjustable pipe connector is €2.40. The activated carbon is €9, and the container and the mesh are €12.99. The price of the activated carbon is based on a price that we found on Wish. We couldn't get a price from the company in Zambia when we contacted them. So that price probably will go down as we bulk buy activated carbon for this filter. The running cost then every month will be €9 to restock and resupply the activated carbon. For the amount of carbon needed for the filtration, so about 10 grams of activated carbon can filter 100 litres of water before becoming saturated. We estimated that the school will use 200 litres a day. Again, this might change when we do further research into how much water the school actually consumes on a daily basis. So about every month, 500 grams of carbon will be needed to last 1 month. Anna, this is your part.
Perfect. So community involvement has always been at the forefront of our project. So we've based the operation and maintenance of our carbon filter around a community-based model. The efficiency of the system essentially relies on locals to carry out daily inspections and maintenance operations. And so we've designed the carbon filter extremely minimalistic and easy to operate if the user's been guided through the process previously. Changing the carbon in the filter is extremely important and can be very dangerous if not done correctly. And for this reason, we seek to educate locals on how to identify when the carbon needs changing and exactly how to do it. These individuals will be highly trained in this process and given the title District Water Officers. And once the filter is in operation, it'll be their duty to overlook and educate further community members on how to change the carbon in the filters. As more carbon filters are installed, experienced district water officers will be required to assign additional water officers to adapt their roles in new areas, creating a multiplier effect that will hopefully expand outside Lusaka. We aim to incorporate women as much as possible in the project's technical elements, as today a stigma surrounding gender roles still exists in Lusaka. We firmly believe that by incorporating women in vital community roles, this toxic stereotype could be removed. And this will be achieved by delegating only women as the initial district water officers. We hope that this would encourage women in the village to get involved in the project and act as inspiration for young women growing up and seeing fellow females adopting these pivotal roles in the community. And thank you very much for listening to our presentation, and if anyone has any questions.
Brilliant, thanks very much, guys. Owen, maybe I'll start with you this time if you have questions for the guys.
Thank you. Yeah, just one question in relation to the disposal of the filter carbon units when they're completed. One, is there an alarm triggering device there? And then two, how is the material collected then disposed of? It is great that you highlight this issue about contamination of lead, and particularly the impact on women, and the concept itself and the way that you're developing it within the community is fantastic. I mean, the water officers is a great idea, but I'm just wondering about, just on the safety element, the disposal of the filtration carbon, how that's intended to be done, and also the alarm system itself and the maintenance. Just those three little things there. Thanks.
Okay, so in relation to the disposal of the activated carbon after it's been used, the recycling facilities in Zambia have facilities in place for toxic waste management. So they will deal with the activated carbon that is full of lead.
Great. I think there was just a couple of other points.
Yeah, what was the
Owen
first
had.
question you had asked again about the...
Apologies. Owen, you're mute there.
Forget to press the unmute button.
Yeah.
The other one was the disposal and an alarm system. When they actually know when the filter is full, and how that's announced really.
Okay, so our team had only looked briefly into an alarm system for this.
filter. So we know that lead does have an effect on the pH of the water. So we were planning on using, going a bit like old school back to secondary school days, and using red cabbage as a way, and do red cabbage pH testers, and using that as a way of testing the pH of the water, and then determining from that whether or not the filter was saturated. Of course, this will all kind of depend on the pH level that's already present in the water in Zambia, and then as well on the amount of lead and zinc in the water in Zambia, because that's quite hard to calculate from the research that I've looked at so far.
Thank you very much. Again, a great concept, and it will be a great idea on the ground. Thank you very much.
Maybe could I ask a
yeah,
question?
Go ahead, Anya.
Oh, sorry, Emma.
No, absolutely. Sorry, I was just closing my window because there's a dog argument going on here. So go ahead.
With your doggy issue, yeah.
Yes.
Sorry about that. Yeah, no, I think it's a really good project, especially because there is, so much contamination from mines and that in Zambia. Yeah, my question was about, I'd say that, how are you going to persuade the women to do this? How will you, like, I'm just interested in how you will, what process you'll use to get women to do this, and will they get paid? Like, will there be something for them? Will they get paid because this is an additional job, or do you think they'll just be glad to do it because they'll have clean water? And also, €9 is nothing to us, but possibly it could seem, how will it be funded? It might be quite a lot if you need that money for school fees or school books. Thank you.
Yeah, I'll take this one. So yeah, as we know, women in Zambia have excessive water demands, and statistically slightly more than men, and they are most susceptible to a lack of water and sanitation facilities. So what we want to do was, initially our first district officer would hopefully come from, say, Ireland, for example, and would educate women. They would surround their team by women and educate them on the process. So once, it's like a chain reaction. So once education, say, is passed from someone from Ireland who's very educated on the matter, we want to pass that to a woman directly. So she would then be in charge. Okay, so then when that woman's in charge and the whole town see a woman with a pivotal role in the town's main water supply, or the school's main water supply, it will then further encourage other women to get involved in the community and get involved in big projects like this.
Yeah, just to add on to that, women are usually the ones who collect the water, so they would be interacting the most with our filter. So we thought it would be good to incorporate them in the maintenance of it.
But it wouldn't be a paid position, it would be a voluntary position, I'd imagine.
Yes, it would have to be voluntary initially. Sorry, do you want to jump in there? Sorry,
I'm saying that as of right now, it is not a paid position, it is voluntary, but hopefully with teaching the district water officers how to operate our filters, but also not just operating them, but how to make their own as well, because our design is quite simple. It's essentially a box with activated carbon inside of it. So hopefully, as well as they learn how to make their own, they can then use that as a money maker, as a way of moving the project on and helping to produce more and sell those to help get the activated carbon for theirs.
Good idea, thank you.
Great stuff, thanks very much, Anne. Pradita, do you have any questions there for the guys?
Well, yes, I would say just a question around I know you guys did mention about having to use 10 gram of carbon filter for 100 liters, and that way have you done cost analysis around that, costing 500 gram of carbon per month? Would that be affordable for, let's say, a family or a community using it? With that, have you guys done any sort of cost analysis around that?
So it was difficult to do cost analysis on our filter because we couldn't get an accurate price for the activated carbon, because we're hoping to source it from Zambia itself and from inside the country. Whereas the activated carbon that we had found online for €9 was from wish.com, so we don't really know where it's from. So we hoping that if we can get the company to come back to us with a proper price for the activated carbon, then hopefully that we're bulk buying it, the price of €9 will drop because we are bulk buying the carbon instead of using just a small amount. So that's what we hope.
Thank you. Another question, I don't know if that's the right question to ask or not, but the container that you guys were showing in the presentation, it's kind of rectangular, right? The hose pipe, for example, it might be 1 inch, pipe coming in, and then there is this, I understand that you guys did give us figure around, what ratio of carbon to be used for what, how much liter of water. But with that container shape and size, would that even matter? Because in the beginning you did mention they would be, because it's a simple design, they could make it on their own, right? So do you have any thoughts around that?
Sorry, so are you asking like development of it, like changing shape over time?
Yes, exactly. Like, the picture that was shown in the presentation, it was a rectangular block. And for example, if they want to, if they can, they are going to make it on their own, the shape would be different, right? And I was just concerned about the ratio that would go inside that. And pretty much, that's the question.
Yeah, so I think at first, like we would be there helping, like so that the ratios would be correct, and then they would be able to know how to make it and make the correct ratios. We would definitely, if they found a better way to have like more carbon or just more efficient, like it's definitely open to design. We just have this because we thought it was the most simplistic and like efficient.
And just to add to that, I think that's one of the key roles of the district water officer. They can regulate and overlook any changes in the design that might happen over years of implementation, and solutions might present themselves as better ways to design it. And that's all part of the education process, but having a suitable prototype to go off is definitely the starting point for us anyway.
Thank you. That was a nice presentation.
Great, thanks, Pradita. And finally, Aravinda, anything you want to share?
Yep, thank you. I had a question on this one. Reflecting back on an earlier presentation about water filtration and quality control, what kind of quality control do we have in place here to say that the water coming out is actually free from contaminants? Is there a way to easily do that? So quality control, how's the quality control ensured in this particular system?
Whoever wants to come in.
Yeah, sorry. That's kind of where the district water officers come in, like making sure that, like doing the tests, like Una said, with the pH, and just make sure that it's actually going correctly. Because if it isn't set up correctly, it can make the water worse. That's why it's in a really pivotal role to make sure that it all goes smoothly.
Got it. I think the second question was in terms of sourcing of I think somebody asked the question about where do we get this constant supply of activated carbon, and how will that be regulated or managed in this environment? Any thoughts given to that?
So we've sourced a company locally in Zambia that do provide activated carbon. We've yet to be in contact as we don't have like an official role with them yet, but we think that if we were to put this on the ground, we'd be able to set up an arrangement. And again, that would be the district water officer's role to kind of keep that like chain going in the supply. We'd have to, because obviously we're working from Dublin, we don't know what the base levels of the water are, but once we got over there, we'd have to run kind of tests and see before and after. So we'd have a base level of pH to compare and go off. And then it would be the district waters officer's job to check it on a daily or weekly basis. Again, this is all to be kind of brought as we kind of bring the prototype to it. But for us, the main thing is to kind of get this on the ground there. And then from there, kind of it will develop and hopefully expand itself.
Got it. Okay. And in terms of maintenance of the mesh, you have a mesh here. how easy or difficult it is to maintain this mesh? Is that replaceable, or you need to take off the whole box off to do something here? Any insights to that?
So yeah, so
sorry, I'll let you
know. Oh, sorry, Anna. So the mesh in the box is basically just cloth or any material that allows water to flow through it. And yes, it is replaceable. So if when in servicing the box and in the maintenance of the box, it can be, someone can tell that mesh either has a hole in it or has worn down, and so people realize that that needs to be changed. We'll teach people as well that needs to be changed, and it can be simply just removed and a new piece of cloth put in its place.
Got it. Okay, and the last question I have is, the water supply pipes, are they made of metal or plastic in wherever we are trying to implement this?
So for the most part, from what I have seen, I'm doing research in Zambia, that most of the water pumps and pipes in Kabwe are made of metal. I haven't seen any that are plastic, but again, I would have to do a bit more research into that. But just from what I've seen, they're mostly metal.
Got it. Okay, thank you. That's from my side, Emma.
Brilliant. Thanks very much.
Good presentation.
Great stuff. Thanks very much, guys. So we'll move on now to our last presenter. Who's our final student from Waterford IT. Certainly, last but not least, Mark McGinley with his presentation on the street. So his focus is on where the excitement of joy in school life is reflected inwards, creating a safe haven of community and freedom. So Mark, over to you.
Hi guys, hope everyone's well. I guess firstly, I'd just like to thank you all for inviting me here today. It's a brilliant experience. And just thanks for letting me present my project. So as Emma said, my name is Mark McGinley. I'm a third-year architecture student in Waterford IT, and today I'll be presenting my design for the Chilea Village School in Zambia. Is that coming through?
Yeah, all good, Mark, yeah.
Yeah, so the way I'm going to walk you through my project today is I'm going to give you a broad idea of my concepts, and where my architectural vision began, and then I'm going to zoom in showing you the site layout, and then I'm going to zoom in again, and I'm going to go into a bit more architectural viewpoints to try and solidify my concepts, and then again further into some of the more nitty-gritty of the project. So I begin with the concepts that started my design process. So I began by trying to understand what makes a school such a special place, and what makes it different to that of other public spaces. So what makes a school, and as opposed to a library or a cafe or a restaurant. So for me, it's the intangible aspects of a school that makes a school so special. A school becomes a place of safety where children can come, let go of the external worries which fill their day, and explore new activities. Schools become incredibly dynamic, creative, fast-paced places, which are packed with joy, laughter, and excitement. So it's these intangible aspects, like the excitement, the joy, the sense of safety, that shaped my design. So conceptually, my school design hopes to create a safe space where the excitement and joy of everyday school life is focused inwards, creating dynamic spaces where kids can be kids. I think that was the main thing, like how can we create a place where these kids can be kids, they can learn through play. And so to begin putting a physical structure to my concepts, I started trying to look at the relationships between the most important spaces in a school. I looked at how the play area, the food area, a community area, and the main school area relate to each other. So that's what these images here are. So what I tried to do is I tried to show what areas link to which. So the say the play area would link to the food and link to the school. So that was what I was going for. From exploring the various organizations, I considered combining the school spaces and the food area along one axis and spanning the community and accommodation zones off this center point. So that's what I was going on for here. So it was this axial concept that kind of resonated with me, and it kickstarted my street idea. Although the profile, scale, and design of our streets vary, fundamentally a street is a void between two solids, and it holds a concentration of human interactions. So a street can amplify everyday human interactions in a safe and confined way. And I really like that idea. I thought it was that idea of confining the human interactions and amplifying them really fed into my concept of creating a joyous and exciting space for these kids. So my school will take the form of 2 streets, which will intersect, creating a dynamic heart of the scheme. Oh, and this will become the scheme. Within the scheme, there'll be 3 types of spaces, and this will be recreational, teaching, and serving. To clearly distinguish these user groups, 2 different roofscapes, which I'll go into later, will be implemented. A butterfly roof will cover the teaching spaces, while a monopitch roof will cover the recreation and the serving spaces. So food is at the heart of the scheme. Oh, sorry. So here we see a 1 to 500 site map, without the roof. So this would be cut at around 2 feet up. So what we see is food is at the heart of the scheme and sits at the intersection of both streets. Here, under the shade of a canopy, students can talk, play, and learn. A school, community, and accommodation street branch out from this focal point. Each street has its own character, which creates excitement for the scheme. So the school street, which we see going from north to south, this would be quite free of geometry. I wanted to be dynamic. I wanted to be quite exciting. I wanted to unfold as you went through the street. When you go to the east, you'd see a community street. This being much more sophisticated, a bit more geometrically regimented. And then when you go down to the west, to the accommodation street, this being much more private, a bit more calm. So just to kind of go through quickly, these blocks here along the school street will hold the kind of the fundamental aspects of a street. So of a school. So you'd have the classroom spaces. You'd also have administration office, a library, you'd have storage, and you'd also have a toilet facility. When you branch off to the community space, we're going to have a community hall. We're also going to have a skill zone workshop. We're also going to have storage and a science lab. And then we're going to have student accommodation and staff accommodation. Within this, the heart of the scheme, this is kind of where this is the most exciting point of the design. So here we want to focus on creating an open, lively space, and it has to be multifunctional. So the community can use the space, the larger community, the smaller community, and the school can use this space. And to have a better look at how this would structure, we have a 3D render here. So the area would be canopied to create shade, but would also be large enough to accommodate larger functions, as well as being one of the main play areas during the day. Just quickly, I'll talk about it later, but the main materials used would be concrete, timber, and corrugated steel, but this will be developed on later. So developing on from the previous site map, this is just a look at the roofscape, and what the intentions here is to create a better idea of how the construction methods create a large shadow, and will attempt to create a more comfortable experience for the kids within the street or the community within their street. So the idea is that these roofs will create enough shade to cover the street for parts of the day. Here's a section through the school street, and the intention of this is just to show or to highlight how the excitement and the human interactions are focused inwards inside this void, which is between 2 solids. And here's a quick look, which I'll go back to, of an elevation of one of the classroom units. It also shows the rainwater harvesting idea, which will be developed later. So here we see a section of the classroom. To talk through quickly, we have the street side on here. We have an external corridor, we have an internal classroom, and we have an external classroom. We learned from our research that the idea of an external classroom is quite popular, because through their culture, they enjoy trying to bring the kids out and teaching them in the open air. So construction methods, I'm going to go for steel trusses. So we're going to have a corrugated roof, about 25 mil. We're going to have steel purlins, 15 by 15 mil, and we're going to have 100 mil steel top and bottom cord. with 50mm struts. An axonometric is coming later to show this. To try and keep it simple throughout the scheme, the construction methods between the different buildings are almost replicated. So for the main classroom unit, which we see one classroom here and one classroom here, we've 10 steel trusses, which will be 2.5 meters separated. And then we see 4 vertical load bearing elements here. And that is replicated through all the all different buildings in the scheme for an attempt to make it simpler to build and easier to manage. Here we're going to look at the floor plans. The classroom unit is going to be 30 students, and it's going to be 6 meters by 10 meters. What we see here is its relation to the street. An interesting design feature this is that the external corridor, which we've seen before, and the internal lobby space is an attempt to kind of slow down the excitement of a kid in the street until he gets into the classroom, he or she gets into the classroom. So the idea is that these kids will be kind of calmed down through these buffer zones. The most interesting part of this is the lobby space. And this will go into the rainwater harvesting. So within the lobby space, we're going to have each classroom is going to have its own wash basin. And the idea is that the kids will be able to come into these areas, wash their hands before and after the class, and then leave. So to allow for this, we're going to have rainwater harvesting tanks at the end of each classroom. And these will be filtered into the sink, into the basin areas. The idea here is that each student will have 2 liters of water each a day. So that would be 3.6 cubic meters. There'll be 2 tanks of this, one to fill normally, and then one is an overflow tank. And in theory, through my maths, I believe that we can almost go 1 full year with harvesting water this way and giving 2 liters a day to each student. And then in any overflow situation, there would be access outside the classroom to these areas. There would also a water pump within the scheme as well. And then as well, we'd have the intentions of the steel truss, or at least this butterfly roof construction, is that the air circulation will be able to come through the openings here and here, but also be able to come out through the roof here.
If you can just bring it to a close now,
Yeah.
Mark, when you're ready. Yeah, thanks.
So this is just a quick look at the construction of the roof. So I'm going to go for steel L beams, and the gutter system will be 100mm by 100mm, with the intention to collect all the water, bring it down to the water harvesting tanks. And then finally, a quick look at how this would look maybe inside the classroom, or at least from street view, and you'd be able to see these exposed steel trusses. So just to recap, so conceptually, my school design hopes to create a safe space where the excitement and joy of everyday school life is focused inwards, creating dynamic spaces where kids can be kids. And my hope is through the streetscape idea that the human interactions can be amplified and the kids can learn through play and be free to be kids at that age. So thanks very much.
Brilliant, thanks very much, Mark. Yeah, whoever wants to jump in there first. Can't see you guys actually, but yeah, or maybe Pradita, if you have questions.
Well, Mark, I really liked your presentation and that concept of your the space design and space. It looks like a really lively space, and like the details on the rainwater harvesting and everything. I've got more or less 2 questions. One is you said that like it's a rough calculation, of course, but then that would that water be you said that they'll be used for hand washing, there'll be that hand washing station, but would that also be useful for drinking purposes? Just a thought over there. What's your take on that?
I think the intention was, well, what I found out was that it was around the 2 liter mark was what I was able to give each student per day. And when I thought about it, I was considering, could it be drinking water? Could it be for hand sanitization? And then with the inclusion of the water pump inside the scheme, I decided to use that 2 litre as a sanitation 2 litres instead of drinking. But in theory, it could become either. It's not, the concept is there, hasn't been fully explored. But I feel like it could, with the butterfly roof and the size of it, I feel like it could, with some, it could cater to both, I feel.
Thank you. My another question was, when you were explaining about the roof, it was not, for me, it was not quite clear. Like, when you were showing the side view of the roof, you said that it's well ventilated. I understand that, but apart from the slanted section, there's this flat area as well, right? If you could scroll the screen, I could explain it.
Is this the one you're thinking?
I think that, oh, yes, this one, yeah. So the flatter section, would there be like anything on that surface, or is it an open, open surface?
I was going to have it as an open surface. I would have had the steel trusses exposed. I guess for one, in an architectural sense, I think it would make the space much more exciting if it was open. I also kind of like the idea that the structure would be able to be understood within the classroom. So I was going to have it as an open space.
Okay, yeah, that's good. Thank you so much. Thank you so much. It was a really nice presentation with you saying like it actually looked like a safe space for kids to move around. It looked really nice. It was a really nice presentation.
Thank you.
Thanks, Pradita. Aravinda, any questions, comments there from Mark?
Yeah, nice presentation, Mark. Again, I was in the original briefing earlier. I think one question, what's the total cost of the project?
That would be unsure. We weren't able to get in contact with any quantity surveyor over there. So I think any numbers that I'd say would be too inaccurate to be worthwhile.
Got it. Okay. Yep. I had no other questions. I can see Owen's face delightful with all these structural things there. Owen, over to you.
Good stuff. Thanks, Aravinda. Yeah, Owen, do you want to jump in there?
I do. Well, I'm actually going to talk about the conceptual ideas, Aravinda. I think the concept is fantastic, Mark. I think the notion of kind of making a streetscape a safe place for children is really a great idea. Again, your presentation skills are excellent, really excellent. And you're very honest as well. I have to make that point too here, because in your conclusion, you do say that you highlight the difficulty in making the trusses out of steel, and that there's further research to be done here. I particularly like this project because it really deals with the situation on the ground in the sense that it's modular. The buildings are modular. They can be reproduced. They can be laid out in any space and any design. And I think I really like that. And it's an easy way for people on the ground to learn how to make a structure and then to remake it. I think that's an excellent idea. The only one criticism I would have of it, and you did highlight it yourself, and you have to be commended for that, is the fact that producing the trusses in steel is a difficulty. I would like to think that after this competition, if we like to call it a competition, I like to call it a volunteering effort, not a competition, that you guys could get together and kind of look at some of the elements again and say, the trusses, the roof, apart from the conceptual ideas and the notion of bringing people into the idea of understanding the knowledge and the capabilities behind the structures, the working of them on the ground is very important. And I think that you've captured that very well. You've kind of just, the idea of using the steel trusses probably is a difficulty for me. So I just want to know the answer to one question. Why did you eliminate timber trusses altogether?
I actually had the timber trusses at the beginning.
Right.
And I think the very beginning was how is a butterfly roof constructed in the first place. So I had to learn that. Yeah. And then I thought that the same, I think timber is going to be the best option for this.
Yeah.
But after developing it, the classroom size expanded a bit, the external classroom size expanded a bit. And I kind of just came to the conclusion that you know, steel is probably the better material for this. But it was wood at the beginning. I think it was just the spans that kind of pushed me away from using wood instead.
Yeah, well, I would say this to all of your colleagues in Waterford as well. The designs are excellent, but do go back and have a look at the spans and the design of the roof structures, and maybe have a second look at it, because all of these buildings are excellent. Thank you very much, Mark. Thank you.
Great stuff. Thanks, Owen. And then to Anne, any extra?
Thank you. Yeah, I had a query about the trusses as well, simply about what the expense might be having, but you've covered that already. So thank you very much. I love this design. I love the idea of the shady boulevards, you know, the idea that there's shade with the roofs there. And when you were talking about your classrooms having space for 30, it made me, you know, very often classrooms that would be common enough here in Ireland, but very often in Africa there'd be much more than that. But you have the idea then that there is an outdoor classroom space as well. So that could be very easily accommodated. There's one very tiny thing. I thought the garden patch, and actually I think that you probably just haven't considered that too much, looks quite small, because I know that in a lot of African schools, the food that they grow there is food that they consume themselves. So I would just make that bigger, but I mean, that's nothing really. That's very easily, you've got space there that you could put more garden patches and more opportunity to grow food. So I don't think I've probably answered my own question, Mark, but have you any comment on the garden?
I think there was aspects to the design that, like, as can be seen in the image here, the detail of the classroom, or sorry, of the staff accommodation, the detail of the vegetation patch is obviously underdeveloped, and probably intentionally underdeveloped, so that time could be spent trying to flesh out, say, the structure or the internal spaces. But I also think that they're allowed to be underdeveloped because there is the space to expand. If it is a size issue, like, they can be developed further. I feel like they're the next steps in the design process.
Absolutely.
I didn't want some of those not exactly that, but I didn't want certain things to take the attention away from the street concept. I wanted to try and keep it really focused to the concept, keep it to the point. I didn't want any distractions.
Okay, thanks, Mark. It's lovely. Thank you.
Brilliant. Thanks very much, Mark, and thanks to all our judges. So yeah, we've reached the end of the presentation.